Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the concurrence as well as feedback regarding the quality of video as well as audio. Is it perfect or not? If it is perfect, just write perfect over the live chat, so at least I'll get to know the videos as well as audios are getting transmitted properly from my side. So I would be waiting for the perfect reply over the live chat. Anyways, the agenda behind today's video is very precise and clear. You can see over the thumbnail of the YouTube and even you can see over the digital board. I am going to take the topmost 10 questions which can be asked in GATE 2021. Either you are from electrical, electronics or instrumentation, and the subject from which the questions has been picked out is nothing but the analog electronics. And deliberately few of the topics I have left, like oscillator I have left. And similarly, I have left the frequency response analysis of the amplifier because few of the topics are there only in a specific branch. Like if I discuss about the frequency response analysis of the amplifier, that is there more or less in electronics itself. Similarly, if I discuss about the oscillator, that is not there in electronics. So what I have done, I have taken only common topic which would be utterly useful for all of the branch. Either you are from electrical, electronics or instrumentation. Perfect, no? And at the same time, I would request to each one of you, try to share this link to your colleagues, your batchmates, your seniors as well as juniors, because all of the 10 questions are utterly properly designed problem. Definitely will give you an insight of the complete analog circuit. A very well designed problem I have taken all of the 10 questions, yes. Anyways, without getting delayed much, let me straight away jump into the first question. So here comes my first question. Just a minute. Here comes my first question. Whenever I show the question over the digital board, always watch the top corner of the problem because it will give you the idea which type of problem it is. You can see very well, it has been written as a MCQ, that means it's a multiple choice type of question. Only one answer would be the correct option out of the four given options. Let me read the problem carefully, and after each and individual problem, once I'll be showing over the digital board, I would be giving around 2 minutes to solve by yourself. If you will not be able to solve, then only you would get familiarized with that problem, so that in future whatever the demonstration, whatever the conceptual details which I would be dealing over here, you would be able to connect it with those parts. Yes. So anyways, let me see what the exact problem indicates. Given figure shows a two-stage CMOS amplifier. Determine its overall small signal mid-frequency gain. We are interested finding its V0 divided by Vin. Assume all transistor in saturation. GM and RD are the standard parameters of the MOS. And now here we have got a circuit where the 4 number of MOSFETs we had, and now we had to get the ratio between the output voltage divided by the input voltage. Output voltage has been taken across this terminal, and here goes my output voltage V0 and here comes my input voltage Vin. The 4 different options are being allocated with this problem. If you'll see the first option, it is nothing but minus GM1, which is getting multiplied with the GM4, and within the bracket it is a parallel combination of RD1, RD2, and similarly multiplication with the parallel combination of RD3 as well as RD4. Similarly, if we hop on the second option or the option B, the gain has been given as minus GM4, which is getting multiplied with the parallel combination of RD1 as well as RD2, and again it's getting multiplied with the RD3 in parallel with RD4. Similarly, option C, it has been given as minus GM1. The multiplication is being taken place with RD1 in parallel with RD2. Similarly, RD3 in parallel with RD4, and the option D is nothing but minus GM1 getting multiplied with the GM4, getting multiplied with the RD1 into RD2, again RD3 into the RD4. Tell me what would be the most answer for this particular problem. How many marks come from this subject? Anyways, first you have to tell your branch, then only I would be able to say something regarding the weightage of this subject. But I would say one thing, keep aside each and everything, just focus over the conceptual details of each and individual problem, and we'll try to smash each and individual problem with a great care as well as with a great concept. Tell me what would be the possible answer for this given problem. What would be the possible answer for this given problem? And yes, from the electrical, so far mostly they were asking the questions related to the BJTs, but from past 2 years they have started asking good amount of problems from the MOS also. So for the electrical, I would say definitely you would be getting one questions from the MOS domain, might be the DC analysis of MOS or might be AC analysis of MOS. This problem is the problem from the AC analysis of MOS. How I am saying it's the AC analysis of the MOS? Because the parameter which I wanted to calculate in this problem, that is nothing but the V0 divided by V in, that is nothing but the voltage gain, and the voltage gain is nothing but the AC parameter. AC parameter. Just wanted to know, any of us could get any of the answer? Any of the answer? No, no. So let me do one thing. Let me copy this circuit and bring it to the next working board. Next working board. Yes, here goes my problem. See, few of the data are clearly written along with this problem. See, what are they? Given figure shows a two-stage CMOS amplifier. Anyways, most of us must be well acquainted how this has been written as a CMOS. You can see very well if you'll talk about this combination and if you'll talk about this combination, they are the two different CMOS comes in. Agreed? How can I say it's a CMOS? CMOS is the series combination of two inverting MOSes, PMOS as well as NMOS. You can see very well the arrow is coming in, that means it's nothing but a type of PMOS, and this is nothing but its source terminal. And similarly, if you'll focus over the MOS number 1, you'll get to know the arrow is coming out, and definitely it's gonna be a type of NMOS. So you can see very well the PMOS and NMOS comes in series. So by default, the combination of these two MOSes would make a CMOS, And similarly, if we'll focus over the M3 as well as M4, again it's gonna be a combination of another CMOS. Why? Because you can see very well the first transistor or the first MOS is nothing but a type of PMOS, the second MOS is nothing but a type of NMOS, and you can see very well they are being connected in series. Now many of us would find this terminology that they are in series. Yes, my dear friends, they are in series. Why? Because whatever the current is possessed by the source 2, the same current would possess by source 1, and similarly whatever the current is possessed by source 4, the same current would possess by source 3. The same current would flow through the PMOS as well as NMOS, PMOS as well as NMOS. Yes. So at least nobody should get afraid that why the word CMOS is being used. So the student who are having a good idea of CMOS definitely would be able to appreciate why the word CMOS has been given along with this problem. So this is one CMOS and this is the combination or the pair of another CMOS. If you want to write a little bit basics behind CMOS, the CMOS is, the name itself is self-explanatory. No, C is nothing but the complementary MOS. That means if one MOS is P, then definitely the another has to be N, and if first MOS is N, the another has to be P. So CMOS is the series combination of complementary MOSes. That means in series you will be having one MOS as a PMOS and the another MOS as NMOS. And as I have been telling that they have been connected and they had to be connected in series, that means both of them would carry the same current. What does it mean by the series? They would be carrying the same current. So you can see very well here, if I say IS for MOS 2, it's IS2, and similarly for MOS it's IS1, both would be same. Agreed? And now CMOS amplifier, determine its overall small signal mid frequency gain V0 divided by V in. Now you can see very well the two CMOSes have been connected in cascaded. Why I am saying they have been connected in cascaded? Because the output from the first CMOS stage is getting connected to the input to the second CMOS stage, and then the output has been taken from the second CMOS stage. So you can say the two CMOS amplifiers, they have been connected in cascade fashion. The output from first CMOS is serving as the input to the second CMOS, and the output from the second CMOS is becoming the actual output from this given circuit. Yes, my dear friends. Now, anyways, I had to be focused on the ratio between V0 and V in. What I am saying, I had to be focused over the ratio between V0 and V in. May I know how we will approach with this problem, or what will be my approach to smash this problem out? What would be my approach to smash this problem out? My dear friends, whenever you are dealing with any type of AC parameter, definitely the AC equivalent of the given transistor has to be taken place. If it is MOS, the equivalent circuit of the MOS has to be replaced with each of the MOSes. If it is BJT, the equivalent circuit of the BJT has to be replaced with each of the BJT. And even the working environment is clearly given, and that is nothing but the small signal, and most importantly, it is being operated in mid frequency range. And if it is operated in mid frequency range, so when you will be taking the AC equivalent of the MOSes, either it's a PMOS or the NMOS, its internal electrode capacitances would be taken as open circuited, and even if you have a external capacitances within the circuit, that would also be taken as open circuited. Although in this problem I do not have any external capacitance. And the next important thing, all of the DC sources has to be removed. If you have DC voltage source, then that DC voltage source has to be short circuited. And similarly, if you have DC current source, that should also become, or that should also be removed, and that would become open circuited. Agreed? So let me do one thing. Let me go into the next page and let me see how the equivalent model of MOS looks like. Obviously it's AC equivalent. So if I'll discuss about the AC equivalent of MOS, either it is NMOS or PMOS. Keep in mind the AC equivalent which I am drawing just after this line, it's equally valid for the NMOS as well as PMOS. Many of the students used to have one doubt, sir. NMOS, PMOS, their polarities are different, even their values of VTH is different. How the AC equivalent could be same for both of them? Anyways, I do not have that much time to explain each and individual details or each and individual differences between PMOS and NMOS. But yes, take one thing as guaranteed, the AC equivalent for the PMOS and NMOS would remain very same. And the environment which I have taken, which is nothing but the small signal, and most importantly, what mid frequency range. That means all of the capacitances would be removed. May I know what used to be its AC equivalent? So MOS is a 3-terminal device. So I have taken source as a common terminal, which would be accessible towards the left hand side, or may I say, or can I say it's the input side as well as the output side? Yes, and as well as the output side. Yes, till this point nobody should have any doubt as such. So you can say this is also the source terminal, this is also the source terminal. The source terminal is accessible from both of the side, input as well as the output side. Now the next important thing, this is nothing but my gate terminal and this is nothing but my drain terminal. And now if your MOS is in saturation region or amplification region, and the operating condition which you have taken is nothing but the small signal and low frequency, then its AC model becomes the input voltage difference between gate to source would decide the output current, and the direction of the output current is being taken from drain to source, and the worth of this current is nothing but the transconductance of the given MOS GM into the voltage difference between gate to source terminal. So here becomes plus, here it becomes minus, and this is nothing but VGS. Yes, and in parallel with GM VGS, here comes drain to source resistance. Yes, that means all of the MOSes has to get replaced with this equivalent circuit, whereas the input which has been taken in between gate to source would be just open circuited. and the voltage difference between the gate to source terminal would decide the dependent current or the current across this limb, which is nothing but the Gm into VGS. Anyways, the next important term has been introduced along with this problem, Gm, which is nothing but transconductance. Transconductance of the given MOS, and similarly RD is nothing but drain to source resistance. Anyways, that solely depends whether the channel length modulation effect has been taken in consideration or not. Yes, if the channel length modulation is neglected, keep in mind the value of RDS simply becomes infinity. And similarly, if the channel length modulation is not neglected or taken in consideration, then it would have its finite value. Yes. Now, whenever you deal with any sort of MOS based amplifier, now you had to replace each and individual MOSes with its equivalent AC. Yes. But at the same time, you also have to have one clarity whether you should have the value of RD or whether the RD has to be neglected and has to be kept as infinity. That solely depends on the datas which are given along with this problem. See, nowhere they have discussed about the early voltage, but still once you go behind the each and individual options, the RD they have been putting along with the expressions. And similarly, not only RD, they have been putting like RD1, RD2, RD3, RD4. By default, they are also considering the drain to source resistance. Yes, drain to source resistance. My dear friends, sir, what is the small signal? I can go into that detail part also, but I don't feel that today's lecture has been meant for that. Yes, so definitely even the drain resistance should also be taken into the picture. So what I would be doing, just try to understand in this way. Let me copy this circuit, bring it to the next working board. See, try to understand how I will decode the problem and would smash the problem probably within 30 to 40 seconds. Just a minute. So just focus over this circuit. Yes, just focus over this circuit. Let me bring this circuit over here. And as I have been interested in finding the ratio between the output voltage to the input voltage, definitely I had to take its AC equivalent. What I had to do? I had to take its AC equivalent. May I know what would be the AC equivalent of 4 different kinds of MOSes? Anyways, you should have a clear-cut idea. The first MOS is nothing but the PMOS, as the arrow is coming in, and the arrow where it has been marked, it's used to be by default the source terminal. So virtually it becomes the source terminal of the MOS2. So by default I can say S2. Similarly, virtually it would become the drain terminal of the MOS2. I may call it D2. Similarly, it becomes D1, it becomes S1, it becomes S3, it becomes D3, it becomes S4, and it becomes D4. Agreed? Yes. Yes, no? Yes. Agreed till this point? Nobody should have any doubt as such. I would request to each one of you at least try to share this particular link to maximum number of people. Definitely all of the 5 or all number of 10 questions are going to teach you many good concepts. Yes. See, tell me what is happening over here. Once you will be taking its AC analysis, all of the DC voltage source which has been connected along with the circuit for just giving biasing to the complete circuit would get short circuited. Like this was connected to the VG2, now definitely would get short circuited. Similarly, this was getting connected to the VG3, it would get short circuited. It was getting connected to the drain voltage, now it would get short circuited. Agreed? Now one more important thing. So may I know what would be VGS over here? what would be the VGS over here? You can see very well the VS is being connected with the ground and even the VG is virtually grounded. So if we'll talk about the VG to S2, definitely for the MOS2 it's simply equals to 0. So if I write VG to S2, it simply equals to 0. It simply equals to 0. Yes, no? At least this point must be easily understandable to all of us. Not only that, if we'll focus over the MOS3, there also, if I would be discussing the potential difference between gate 3 as well as source 3, that is also 0. That is also 0. Why exclusively I am focusing over the VG2 S2? Why I am focusing over VG3 S3, my dear friends? My dear friends, try to understand in this way. If VGS itself is 0, my dear friends, the output dependent current would become 0. That means that MOS would only be replaced by a RD, and that too in between drain to source. Agreed what I am saying? I would repeat this fundamental once again because it's an utterly important fundamental. What I am saying, although they might be connected with the VG2, they might have been connected with the VDD, it might have been connected with the VG3, but once you are calculating the gain offered by the given system, you are doing its an AC analysis, and when we do the AC analysis, all of the external DC sources has to be killed out. That means if it is a voltage source, it has to be short circuited. If it has been a current source, it has to be open circuited. You can see very well this becomes short circuited, this becomes short circuited, this becomes short circuited. That means in future, if I will redraw this circuit would become an utterly simple circuit. How? It would be just replaced with the RD, and as it has been in the place of M2, I will just be writing it RD2, and similarly this would get replaced with RD3. Agreed what I am saying? So let me do one thing, let me copy this out and bring it over here. So what are the changes I would be proposing? So first proposal which I would be giving, just replace this complete MOS and place RD2 over here. Yes, similarly just replace the complete MOS, put RD3 over here, and even this VDD has been connected to the ground, So the change which I would be proposing over here, just put this as ground, similarly just put this as RD2, and similarly just put this as RD3. Yes, just put this as RD3. Agreed, no? Now here the replacement has to be done properly. How the replacement would be? Now because the Vin is the actual or the factual input, so definitely the GM VGS component would be a non-zero component. So definitely you will be having a GM into VGS. Which GM has to be used? You had to use the GM of MOS1. So here it's gonna be GM1 into VGS. What's the VGS? The VGS is nothing but the potential difference across the gate to source, and that's simply equals to Vin. And now in parallel with that, there would be a drain resistance, and as the drain resistance has to be offered from the MOS1 has to be used as RD1. So what I would be doing, I would be just rubbing this out. And the two component would be coming over here. What are they? The first would be a dependent current source. May I know what would be the worth of that dependent current source? That would be GM. For the first transistor, it would be simply GM1. VGS, if you'll see what was the VGS, the VG is being connected with the Vin and S has been connected with the physical ground. Simply I may write this as Vin. And in parallel with this, definitely now you would be having a drain resistance for the MOS1, simply it would be RD1, my dear friends. Even the person or the student who are well acquainted with the concepts related to the MOS, straight away they can jump into this particular circuit, and once you come across this particular circuit, probably you would be able to get the value of V0 divided by Vin within 30 seconds. Although I have traveled with so many different concepts, but still what I am saying, if you are thorough with the MOS, and if you are not at all thorough with the MOS, then also I will give you a little bit idea. See what I am saying, just try to focus over this circuit. You are wanted to calculate the gain offered by the system, that means the ratio between V0 and Vin. Definitely you are forced to apply the AC analysis. In case of AC analysis, what we do, all of the internal capacitances become open circuited and all of the external capacitances become short circuited. It is short circuited. Yes. Although I do not have any external capacitances, so definitely I'll be keeping each and everything aside. And what does that mean by the keeping external capacitances? Open circuited, that means once you will be taking the equivalent circuit of the MOS in AC platform, you will not be having any capacitances in between any of the terminal, yes. So what I am going to do, just try to understand what I am saying. Whenever you have this sort of problem, no, I would repeat once again, whenever you have this sort of problem, what I am saying, whenever you are seeing this sort of problem, and if you are focusing over finding the gain offered by the system, may I know? Gain, maybe a voltage gain, maybe a current gain, maybe a trans resistance gain, maybe a trans conductance gain. Which type of analysis has to be done? Obviously the AC analysis has to be done. If you are doing the AC analysis, all of the transistor has to get replaced by its AC equivalent. And what about the AC equivalent of the MOS? First you had to see the voltage difference between VGS. The VGS would decide the output current, that's nothing but the GM times of VGS. What is the GM over there? The GM is nothing but the trans conductance of that given MOS. And what's the RD over there? The RD is nothing but the drain to source resistance, So what I am going to do, I am going to replace that circuit over here, that circuit over here, that circuit over here, that circuit over here, yes. And once I am doing the AC analysis, all of the external DC sources has to be killed. So what I have done, see, try to understand what I have done. I have kept this VG2 as ground, and if I have kept that VG2 as a ground, so by default in AC equivalent model the VG2 became 0. This was my bias voltage that also had to become 0. So put together the VG2 and S2 became 0. So in future the replacement of the M2 which has to be taken place, which becomes GM into VG2 S2, that becomes 0. That means that becomes open circuited. If the current becomes open circuit 0, that becomes open circuited. Yes, no? That is what I am doing, my dear friends. Could you understand what the exactly sir is saying? Within 30 seconds you would be able to crack any sort of problem. Although I have given so much amount of time for the first problem, but within 30 seconds you would be able to crack this problem out. You have this circuit, you wanted to get gain of it. First what you do, all of the DC sources you had to kill. If it is voltage source, put it short circuited. If it is current source, put it open circuited. So this became short circuited, this became short circuited, this became short circuited. Nobody should apply this as a short circuit. Why? Because this is my physical input. Now you can see very well. Here V in is live, so definitely the complete replacement has to be done in place of M1, which we have done it. Now here VG2 S2 is 0, so definitely GM VG2 S2 became 0, and as the current becomes 0, it becomes open circuited. Only RD2 would come on a picture. Similarly, if we'll talk about the M4. Now, if I talk about the M4, my dear friend, if I talk about the M4, tell me only the drain resistance would come into the picture, or even the GM would also come into the picture. My dear friend, here it is gate, and here it is source. Although the source became 0, but nowhere it has been clearly visible that the gate potential have become 0. That means nowhere I can say the VS4 or the potential differences between VG4 as well as VS4 is 0. That means I cannot replace this M4 with only and only with its drain resistance. I have to replace with its complete model. May I know what it used to be the complete model? The complete model would be very same. You would be having a gate, everything. So tell me, how would be the complete model? The complete model would be, let me do one thing. In between drain to source, there would be the replacement. There would be a replacement. The direction of current is utterly important. If you do somewhere mistake, no, you are just out. The flow of current would be from drain to source. The drain terminal is this terminal, source terminal is nothing but this terminal. May I know what would be the amount of flow of current? It would be GM for the transistor 4, it's gonna be 4, and similarly here it's gonna be VG4S4. May I know what is VG4? VG4 is nothing but the potential across this terminal. For the time being, I may take the potential across this terminal as Vx. So simply it becomes Vx. And similarly, the worth of the resistance for the drain 4, it would be simply RD4. Agreed? Now easily you would be able to figure it out, the value of V0 divided by V in. Tell me how much worth we would be getting. how much worth we would be getting. It's very easy to calculate. It's very easy to calculate. See how I would be doing. First, I would be focusing over the Vx. I would be focusing over the Vx. So the Vx, you can take the KCL over the Vx. So Vx minus 0 divided by of RD2. RD2. Similarly, Vx minus of 0 again divided by of RD1. And here this current is leaving from the Vx, it would be taken as GM1 into Vin, and that has to be compared with 0. That has to get compared with 0. Yes. So from here easily I would be able to get the value of Vx, which would be equals to of minus GM1 Vin. It's nothing but the 1 upon RD1 plus of 1 upon RD2 would go towards right hand side, would become 1 divided by of RD1 plus of 1 divided by of RD2, and you had to take the inverse of it, and you can simply say it's a parallel combination of RD1 as well as RD2. So why don't we write here itself? So here it becomes the parallel combination of RD1 as well as RD2. RD1 as well as RD2. RD2. Yes, my dear friends. And now this data has to be fed across this particular region. And once you know the value of Vx, and that too in a form of Vin, definitely you would be able to get the value of V0. May I know how will you? See again a little bit change I am proposing over this limb. This is nothing but V0. The V0 has been connected with, try to understand in this way, it has been connected with the RD3. RD3 is being connected with the ground. Now similarly V0 has been connected with RD4, and even the RD4 is also getting connected with the ground. Yes, and now the V0 is being connected with a current source. May I know what was the direction of the current source? The direction of the current source was leaving from V0 and was going towards the ground. Towards the ground. Yes. So here, may I know what was this current? This current was GM4 into of Vx, and the value of Vx is clearly known to me. So may I know what would be the V0? The V0 would be the current, and that too now the current has to get reversed now. Tell me how much exact answer we would be getting out of this. Tell me. Now the turn goes to you guys. How much exact answer we are getting for this particular problem? Tell me. How much exact answer we are getting for this particular problem? So I am waiting for the reply. I wanted to get the value of V0 divided by of Vin. Tell me exactly how much answer we are getting for this particular problem. See here what is happening over here. So you can just switch this direction of current. So here it would become minus of GM4 into of Vx RD4 in parallel with RD3. Yes, my dear friends. And now what it happens? Here it becomes minus of GM4 Vx. What is the Vx over here? The Vx is nothing but minus of GM1 Vin within the bracket RD1 parallel with RD2 is getting multiplied with RD4 in parallel with RD3. Yes. And the minus and minus sign becomes plus, and put together the ratio between output to the input voltage, which we got to know, it's simply equals to of GM4 RD1 in parallel with RD2 into RD4 in parallel with RD3. You can see very well this was the appropriate answer. Yes, just wanted to know, could you understand what exactly I wanted to communicate with the help of this problem? Again, I would say, this was your given circuit. You wanted to get its gain. Whenever you have this sort of circuit, you had to follow this methodology only. Yes, if this is your given circuit, you wanted to get its gain. My dear friends, many of the MOSFETs, no, they would just be replaced by their drain to source resistances. Why? Because they have VGS is equals to 0. Like here you can say VGS is equals to 0 got replaced with RD2, and similarly here also is the value of VGS is equals to 0, so it would get replaced with the RD, and in position of 3, so it's simply written as RD3. But now in case of M1, the value of VGS is not 0, it simply equals to of V in. So definitely I cannot keep this current source as 0, which is used to be open circuited. I had to feed the complete data, which is nothing but the GM1 V in. The direction of the current would always be from drain to source. That is why it has been taken from drain to source. That's the first thing. And in parallel with GMV in, you would be having a RD1 that is also being taken. That is also being taken. Yes, that is also okay. And now if I come across M4, here again you can see the gate is getting connected to a certain node, and here the potential is not 0. That's the different story together. The S is 0 over here. The S is 0 over here. That is why I did not take all of the components. I have just taken GM4 Vx along with the RD4, and I have calculated each and every details, and at last I got the answer. Tell me, could you understand? Could you understand what actually I wanted to say from this particular problem? Yes, so the first question is over, and if you'll say what was the best most answer? So obviously the best most answer was plus GM1, GM4, RD1 in parallel with RD2 getting multiplied with the RD3 in parallel with RD4. Yes. Yes, no? Yes. Anyways, agreed, no? Now, it's the time to take the next problem. Here comes my second problem. Yes, here comes my second problem. Probably many of us would be able to at least analyze this problem, because it is comparatively simpler problem as I have taken the last problem. Tell me, what would be the appropriate most answer for this given problem? Let me read the problem first. Assuming the diodes to be ideal, that means in future if the diode goes into the forward bias, by default it becomes short circuited, and in future if the diode goes into the reverse bias, by default it becomes open circuited. No value of RF, V cut in, anything is not being given. It's a pure ideal diode. Then following are the correct statement. That means you can have more than one appropriate or correct options. Even you can see from the category of the problem also, it's a type of MSQ type of problem. The 4 different options were attached along with this problem. What is the first option? The first option indicates D1 is off and D2 is on. That's the first option. The second option, D1 and D2 both are on. Value of I has been precisely written over the current across the diode, and V are 1 milliampere and 0 volt respectively. That means you have to calculate the current across the diode 1, and at the same time you have to calculate the voltage across the diode 2. Not exactly diode 2, you have to calculate the voltage across this terminal. Obviously, whenever we calculate the voltage across any of the terminal, we used to take the reference of ground. So nobody should get confused that they had to calculate the voltage across the diode. No, my dear friends, this terminals has not been taken across the anode as well as cathode. This potential difference has been taken across the anode terminal of the diode, taking the reference of the ground. So nobody should get confused like it is the voltage across the diode D2. No, it's just a purely potential across this terminal taking the reference of ground. Now the D option, which is a utterly important option, deliberately I have designed the option D just to make you understand the good concept of the diode. If the value of 10 kilo resistance made lower than 5 kilo, what I am saying, if the 10 kilo has been lowered and has been brought lower than the value of 5 kilo, then the state of D1 changes. What it says, the state of the D1 would change, and it would change from on to off, whereas the state of D2 remains same. Anyways, after watching this problem, you guys could have figured it out what this problem states for. The diode D1 and D2, they are the ideal diodes. If they are in forward bias, they would be short circuited, and if they are in reverse bias, they would be in open circuited. So taking the reference of this circuit, you had to smash these 3 options out. First, you had to get the state of each and individual diodes. Out of 2, which is on, which is off, both are on, both are off. That they are the starting 2 options. Then once you are thorough with the states of each and individual diodes, you have to get the current across the D1 as well as the voltage across this terminal. That would be my first agenda. Tell me how we will proceed further, and what are the different options are the appropriate or the correct options for this given MSQ. I would be waiting for the next 1 minute, and then straight away I'll hop into this problem and I will try myself to solve this problem. Anyways, I would be giving around 1 minute to each one of you to try this problem out. Tell me, what would be the best most answer? Tell me. Let me see what are the different comments you guys are having. Tell me, what would be the best most answer for this given problem? Tell me. What would be the best most answer for this given problem? Tell me. See, my dear friends, try to understand how to smash this sort of problem. For the better visualization, what I am going to do, let me copy this problem and bring it to the next working board. And I would just be focusing over this circuit. Yes. Now, whenever you come across a circuit which contains more than one diode, I will give you a little bit idea how to handle those sort of problem. My dear friends, out of 2 number of diode, no, at least you would be able to figure it out. One diode would be always on or would be always off, irrespective of the resistances values. So may I know, out of D1 as well as D2, would you be able to say something that the D1 or the D2 would be pakka on or pakka off? Both diodes are on. Pakka on or pakka off. See, my dear friends, try to understand in this way. If we will be focusing over the D2, no, focus over D2. Focus on D2. If you apply short circuit test along D2, yes, that means we have taken the D2 is in on mode and that has been taken as short circuited. And if it has been taken as short circuited path, you can see very well, because of plus 10 volt, there would be a flow of current from positive polarity to the negative polarity. Definitely the force of current would be from anode to cathode. Yes, and not only that, even because of minus 10 volt, there would be a force of current from anode to cathode. I am not saying anything about the D1. So one thing is quite sure, if we discuss about the D2, there are the 2 different sources. Because of plus 10 volt, the D2 is forced to operate into the forward bias, and because of minus 10 volt, again the D2 is being forced to operate into the forward bias. What does it mean of it? That means one thing is quite self-explanatory, irrespective of the value of 10 kilo and 5 kilo. See, my dear friends, if you increase the value of 10 kilo as well as 5 kilo, the flow of current may decrease, but the direction will not change. Put together, the D2 would always be on. So what I am saying, even with the help of short circuit test, I got to know the flow of current is from anode to cathode. Either I take the impact of plus 10 volt or minus 10 volt. That means sure shot, the D2 is gonna be in forward bias. Yes, my dear friends. Similarly, even if you apply the open circuit test, what does it mean by the open circuit test? At very beginning, I have assumed this diode is off. Yes, if this diode is off, what does it mean of it? That means it is not going to allow any sort of current across it. If this diode is off, there would not be any flow of current across the 10 kilo. This 10 volt straight away would jump across the D2 or the anode of the D2. So now what I am seeing, again focus over D2, and now the test which I am performing, it's nothing but the open circuit test. You can perform either of the test. If you are comfortable with the short circuit test, you can go ahead with the short circuit test, and if you are comfortable with the open circuit test, you can just go ahead with the open circuit test. Agreed? So here, if I apply the open circuit test, definitely VA became 10 volt, 10 volt. And similarly, if I would be discussing about the Vk, if I would be discussing about the Vk, now, try to understand in this way. If the diode 1 is on now, in that case the Vk would be 0 volt. So the Vk have got the two different possibilities. Either it could be 0 volt when the D1 is in conducting mode. I do not know exactly the state of the D1, so I would be keeping each and everything aside. Yes. And similarly, if the D1 is short circuited, Vk would be 0, and if D1 is open circuited, definitely there would not be any flow of current across this diode. That means this is the only path through which the current can source or sink, and you can see very well the D2 is off. That means this minus 10 volt would become the voltage across the cathode, which is nothing but minus 10. So either you take the reference of 10 volt with 0 or 10 volt with a minus 10. Keep in mind, what does it mean of Va minus of Vk? The value of diode voltage which I am getting now, if I subtract 10 minus 0, which is plus 10, and similarly if I subtract 10 minus of minus 10, again it becomes plus 20, which indicates the potential difference between anode to cathode terminal across the diode is positive. That means whatever the assumptions you have taken now, that assumption is utterly wrong. That assumption is utterly wrong. Probably the one doubt I am seeing over here, the Desi gun is saying it is not clear why the diode 2 is on. My dear friends, what I am saying, if you assume this diode is on, the force of current because of plus 10 is towards downside, and similarly the force of current because of minus 10 is again towards downside. So the flow of current is always forced from anode to cathode. D2 has to be on. That's nothing but a short circuit test. Even you can apply the open circuit test. Although I am writing each and everything over the digital board, so probably it might be taking long amount of time, but otherwise if you guys are well acquainted with the diode related problem, within 5 seconds you would be able to judge the D2 would be on anyhow. Similarly, if you apply the open circuit test, for the time being you have assumed, sir, I do not know about the D2, so I have assumed the D2 is off or in reverse bias. So what I would be doing, I would be checking the voltage across the anode. So the voltage across the anode is simply 10 volt because there is no flow of current across the 10 kilo, the same 10 volt will come over here. Now I do not exactly know about the state of the D1. If the D1 is on, this would become 0. So the potential difference Va minus of Vk is precisely plus 10 volt. And if this diode is off, the potential difference across the Va minus of Vk is plus 20 volt. Both indicates whatever the assumptions you have taken now. Whatever the assumptions you have taken, that seems to be wrong. This diode is not off, this diode is on. Just wanted to know from each one of you, how many of us could have figured it out that diode 2 would be on at any case, whether the D1 is off, whether the D1 is on. In either of the case, the D2 would always be on. D2 would always be on. Just wanted to know from the comment, So one thing we could figure it out from this problem, what it is, sir? D2 would be on anyhow. Yes. So why don't we replace this circuit with the short circuited diode? Yes. Now it becomes a comparatively simpler circuit. Simply this D2 would be replaced with the short circuited path. Yes. Yes, my dear friends. May I know there is autofocus sort of problem? Let me check it out. Just a minute. Let me check it out. Few feedback I am getting. So probably now each and everything must be okay. Yes. No? Now may I know what would be my next agenda? My next agenda would be to know the state of D1. Again, you can perform the open circuit test or either you can perform the short circuit test. The choice is yours. Open circuit test. When I would be performing the open circuit test, I would be assuming the diode D1 is off. diode D1 is off, and I would be calculating the voltage difference across this diode, which is nothing but the VA minus of VK. So okay, for the time being keep this diode off. For the time being keep this diode off, yes. And if you are keeping this diode off, may I know what's the potential you would be getting across the terminal B? Easily you can get with the help of few number of KVLs as well as KCLs. If you want, I can do that. This is nothing but the B terminal. Along with the B terminal, the 5 kilo gets connected. The 5 kilo is getting connected with a minus 10 volt, and similarly along with this, the 10 kilo is getting connected, and the 10 kilo is getting connected with a 10 volt, and that is nothing but the plus 10 volt, and here it's nothing but VB, yes, that's nothing but the voltage across the terminal B, So how will we calculate the value of VB? Obviously we would be applying the KCLs. So here it becomes VB minus of minus 10, that becomes plus of 10 divided by of 5 kilo, plus here it becomes VB minus of 10 divided by of 10 kilo is equals to 0, Now you can see very well in the first term as well as second term, 5 kilo is common, so definitely 5 kilo can be snatched out, can be shifted towards 0, and definitely the factor which has been left out is simply gonna be VB plus of 10 divided by of 1, VB minus of 10 divided by of 2 is equals to 0, yes. And now if I will be taking the LCM becomes 2 times of VB plus of 20 plus of VB minus of 10 is equals to 0, Let me add them together, So here it becomes 2VB plus of VB, that's simply equals to 3 times of VB, and the 20 minus of 10 would become plus 10, the plus 10 would go towards left hand side, would become minus 10 divided by of 3. What does that mean of it? After the open circuit test, the value of VB which you could calculate, it simply equals to of minus 10 divided by of 3, and now you can see very well whatever the assumptions you have taken, no, that is utterly wrong assumption. What the assumption you have taken? The assumption which you have taken that the diode is off, my dear friends, the diode cannot be off. Why? Because now you can see very well the voltage across the cathode, which is nothing but the VB. You can see very well the voltage across the cathode, which is nothing but the VB, is equals to of minus 10 divided by of 3, whereas the anode is being connected with 0. So when you will be discussing about the potential across VA and VK, which is at higher potential and which is at lower potential, VK is nothing but the minus 10 by 3. Definitely it's lower than the VA, which is kept over the ground. That means whatever the assumptions you have taken, no, that is utterly wrong assumption. That means now this diode has to be taken as on. Otherwise you can even apply the short circuit test also. All of the methodologies let me discuss over here. I won't take much time. I would just go in the fast track. See, in case of open circuit test, we got to know, obviously sir, this diode although has been taken as open circuited, but it has been found that the diode is in forward bias, so it has to be kept as a forward bias. Agreed? Now rather taking the open circuit test, if any of the student takes short circuit test, then also he will be getting to know that yes, whatever the calculation you have done it, know that the diode D1 is on, again it would be in on condition. So short circuit test, what it says, we know the D2 is already on, so anyways keep this as short circuited. Now what I have done, even I have taken the assumption that this diode is short circuited, that means it is working into the forward bias. How will you ensure real it is working in forward bias or not? You had to calculate the current across this limb. If the direction of the current is from top to bottom, the top was anode terminal and the bottom was cathode terminal, that means really the short circuit test approximation is a correct approximation and the diode is really short circuited or working into the forward bias. Otherwise, if the direction of the current is just opposite, that means whatever the assumptions you have taken, that assumption is utterly wrong. May I know what would be the amount of current I? Simply this can be calculated. How? See my dear friends, this is 0, this would also be 0, this is nothing but 0 volt. You can see very well the current flows from higher potential to lower potential, it is being kept at 0, this is being kept at minus 10. So obviously it is at higher potential, it is at lower potential, the flow of current would be 0 minus of minus 10, that becomes 10 divided by 5, and simply 2 milliampere current would flow across this limb. Yes. Agreed, no? No. Focus over this limb. My dear friends, this is being connected with the ground. Now this is also at same potential. So you can see very well that 10 minus of 0, there would be a flow of current from higher potential to lower potential. 10 minus 0, that's simply 10 divided by of 10, that's nothing but 1 milliampere. My dear friends, the 1 milliampere current is coming across this junction from right to left. My dear friends, just to satisfy the requirement of the KCL, this is 1 milli, this is 2 milli, the additional 1 milliampere of current has to come through this branch, and that too from anode to cathode. So even from the short circuit test, you could figure it out, the same concept. What it is, that the diode is on. Diode is on. See, such a nicely designed problem it was. It is not a tough problem, but yes, probably within 1 minute you would be able to crack this problem out. D2 is always on. Either you keep 10 kilo, 5 kilo, 20 kilo, whatever it might be, it is always on, because the 10 volt is also forcing the current towards downside, minus 10 is also forcing the current towards downside. It became short circuited. Once it became short circuited, analysis of D1 became so easy. What we did, at very initial I took D1 as off, but once I took D1 as off, I got to know the VB is negative. That means my assumption was wrong, sir. It is not open circuited, it is short circuited. Yes. Secondly, now you have assumed that sir D1 is short circuited, and now you had to show that yes sir, this would be short circuited provided there would be a flow of current from anode to cathode. From the open circuited test as well as short circuited test, I got the same result. So the D1 is on, D2 is also on. D1 is on, D2 is also on. Yes. So let me do one thing. Let me copy this circuit towards this side, Yes. Replace both of the diodes D1 as well as D2 with a short circuited path, with the short circuited path. Here it goes short circuited, here it goes short circuited. And we were interested finding the value of V as well as we were interested finding the value of I. Yes. So taking the reference of this circuit, you would be easily able to get the value of I as well as V. May I know what would be the value of I? What would be the value of I, which we have already calculated? See my dear friends, is 0 minus of 10, that's a 10 divided by 5, that's nothing but 2 milliampere. Similarly, it's a 10 minus of 0 divided by 10, that's nothing but 1 milliampere. So the remaining 1 milliampere of current has to come through this path. So the value of I is known to me. So the value of I is simply gonna be 1 milliampere. Yes. And if I would be wanting to calculate the value of V. May I know what would be the V over here? What would be the value of V over here? Just tell me, what would be the value of V over here? What would be the value of V over here? My dear friend, it's nothing but the potential across this terminal taking the reference of ground, my dear friend. This is also ground only, no? So if you'll see, the potential across this terminal is at 0 volt. This is also at 0 volt. 0 volt has been calculated taking the reference of 0 volt. So obviously the value of V is simply gonna be 0. Yes. Yes, no? Now here goes the third outcome. The last statement. If the value of 10 kilo resistance made lower than 5 kilo, then the state of D1 changes from on to off. Already it has been seen when the worth of this resistance was 10 kilo, the state of the diode 1 was on. Now it is asking if the value of 10 kilo resistance has been brought lower than the value of 5 kilo, whether there would be any change of the state of diode. Would it go from on to off? Yes or no? Anyways, I would give around 30 seconds to all of you just to say yes or no whether the option D is a correct option or not. Tell me whether the D is a correct option or not. Tell me. My dear friends, try to understand what I am saying. See. Initially, D1 was taken short circuited. Yes. When the worth of resistance was 10 kilo as well as 5 kilo. Yes. If this was taken as short circuited, there was a constant flow of current. May I know how it was? How much it was? It was nothing but 2 milliampere. That is nothing but 10 divided by 5. That is nothing but the 2 milliampere. And similarly, there was the flow of current, and that is nothing but the 10 minus of 0 divided by of 10 kilo, and that is nothing but 1 milliampere. Yes. And as it is 1 milli, it is 2 milli, the remaining current was coming from the diode, which was a on diode, which was 1 milliampere. But what is happening over here? I have given a condition that 10 kilo is continuously lowered. Keep in mind, if 10 kilo would be continuously lowered, definitely the direction would remain same, but the magnitude would be keep increasing. Why? The current which is flowing across the 10 kilo is same as 10 minus 0 divided by the worth of the resistance. If the worth of the resistance is decreasing, this amount of current would increase. Like it will go to 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and as it reaches to 2 and beyond 2. If it goes beyond 2, my dear friends, again here the direction or the magnitude was fixed to 2 milliampere, and here the flow of current which has been forced by the 10 volt is greater than 2 milliampere. So the remaining amount of current would try to pump the current in diode 1 from cathode to anode, and the diode would become off. But that situation will never be arrived with the D2, because the flow of current across the D2 is always smooth from top to bottom, taking the reference of 10 volt, taking the reference of minus 10 volt, whether you are keeping 10 kilo, whether you are keeping 5 kilo, whether you are keeping 2 kilo. So may I know, if I reduce the worth of 10 kilo lower than 5 kilo, whether the state of diode 1 would change or would remain very same? Tell me. I want the answer from each one of you. So let me see any sort of comments you guys are having. Tell me, fatafat. So how will we check? Just try to understand in this way. Again, the short circuited test has been conducted. I have assumed the D1 is on, and if the D1 is on, definitely the flow of current across the D1 always has to be from anode to cathode. Yes, for the time being the D1 is being taken on, and the current across the 10 volt is being taken as 10 volt minus F, as it is short circuited, the potential across the terminal B is nothing but 0, divided by 10 kilo. Exactly, I do not know how much resistance I want over here. I have written this as R critical. Yes, my dear friends. Similarly, here this current is simply equals to of 0 minus of 10, that's a plus 10, divided by a 5, that is nothing but 2 kilo. Just a minute, that is nothing but 2 kilo. So for the time being, let me rub this out. It's nothing but 2 milliampere. Until and unless the flow of current across this limb is more than this limb, there would be additional current across the diode, which will force the amount of current of the diode from anode to cathode, and the diode would remain on. Otherwise, if the situation becomes just reverse, what I am saying, if this current becomes more than this current, what would happen? Tell me. If this current becomes more than this current, what would happen? The diode 1 would be in great danger, and the diode 1 would go into the reverse bias. Yes. So this is the condition to keep diode on. Diode D1 on. So here it becomes 10, 2 milli, R critical. So the value of R critical has to be greater than, and even you can take the reference of boundary, 10 divided by of 2 milli, which is equals to of 5 kilo ohms. So you can see very well, if the value of R, or I can say R, is exactly equals to of 5 kilo, then it is been at critical condition. If the value of R is greater than RCR, what does it mean of it? That means it is, the diode 1 is in, I can say one thing, the RCR is equals to of 5 kilo. If the value of R is greater than RCR, the diode 1 would be on, and similarly, if the value of R over here is lesser than RCR, the diode would be off. Agreed, no? Tell me, till this point each and everything is clear or not? If it is clear, just write clear over the live chat, so at least I will get to know each and everything is properly communicated. Now, how we could have solved in gate examination? How we could have solved this problem into the gate examination? At very beginning, what they have been asking? They have been asking about the states of the diode. As I have been telling, always search for a diode where you can make a bet, definitely that diode would be always on or always off. You cannot say anything about D1, but yes, you can say everything about D2. Either plus 10, the flow of current would be this, either minus 10, the flow of current would be this. So D2 would be always on. Yes, if D2 would always be on, so either A could have been the proper answer or the B could have been the proper answer. Whenever I am saying, whenever you are thorough with any of the diode, do one thing, replace that complete circuit with the improved version of that circuit. Because again and again, if you are placing the same diode, no, unnecessarily you are making that circuit complex. See, now you have come across a circuit which contains only one diode. Now, you can assume this diode as off, and after doing the open circuit test, you had to ensure the voltage across the cathode was greater than the anode. And if it is true, definitely whatever the assumptions you have taken, that assumption is very perfect. But when I applied or when I performed the open circuit test, I got to know the value of VB is lesser than 0. That means whatever the assumptions I have taken across the D1, which was found false, the D1 is on. That's it. You can apply the open circuited test. Either you can apply the short circuited test. You need not to apply both unnecessarily. You would be spending your time. So we got to know, yes sir, the D2 is on and the D1 is also on. Now, if we were interested finding the value of I, obviously we can get this value of I. How? Sir, I know this current. How much this current it is? 0 minus of 10 divided by 5 kilo, that's 2 milli. 10 minus of 0 divided by 10, that's nothing but the 1 milli. So the remaining current has to come across the D1, which is on, which is nothing but the 1 milliampere, Similarly, if we'll be discussing about the voltage across this terminal, my dear friends, this has been connected to the physical ground. That means this potential would come all the way till this point. You can see very well. This is also kept over the ground potential, and the potential difference has been taking the reference of another potential which is at same potential, ground potential, it would be simply 0. Now the next, the D option, I know many of us would trap over this point. If the value of 10 kilo resistance made lower than 5 kilo, then the D1 would change its state, whereas D2 will remain same. Obviously sir, D2 will not change its state. How the D1 would change? As the value of 10 kilo is decreasing, the more and more current is getting pumped, and as the more and more current is getting pumped, do you know that there is no change of current across this limb? It is fixed to 2 milli. So as the current is increasing, now the diode is in big danger. In future, it may be forced to carry the current from cathode to anode, and that has happened. And that has happened at the resistance of 5 kilo. And as the resistance across the 10 kilo has been replaced to 5 kilo, and if the resistance goes lower than the 5 kilo, there would be a force of current from cathode to anode. Definitely diode has to be taken as off. Yes? Yes, no? Yes, so probably this part must also be clear to all of us. So second question is also done. Let me move into the third question. Here goes my third question. It is a utterly delicious problem. Such a thick amount of network analysis is required to smash this problem out. Anyways, let me read what the problem states exactly, and then we'll try to decode this problem. See what the problem states exactly. Probably it must be visible to all of us. It's a type of MCQ. That means only one option would be a correct option for this particular problem. In the circuit shown below, beta is equals to 65 and VA. Anyways, what does it mean by the VA? It's called the early voltage, is equals to 75 volts. VEB on is equals to 0.7 volt. V thermal is equals to 26 millivolts. Now you have been allocated with a circuit which contains a PNP type of transistor. Note, BJT is operating in amplification region. That means it's been operated into the active region. The transistor parameter R pi, probably most of us must be well acquainted with this parameter, and R naught, and a small signal mid frequency transconductance gain GS is equals to I naught divided by of VS is. The four options were given. The first option was dedicated towards R pi, the second option was dedicated towards R naught, and the third option was dedicated towards the GS. Yes, tell me what would be the best most answer for this given problem. Anyways, I would be giving around 1 minute to all of us, and anyways, once we'll solve this problem, probably we are going to take around 5 to 7 minutes, because it is a sort of long problem. Tell me what would be the best most answer for this given problem. before going to do the thick analysis with this problem, let me ask few number of problems. The first problem I would be asking, how will you get the value of R pi as well as R naught? Should I be using the AC analysis along with this circuit, or should I be using the DC analysis with this circuit? Should I be using the AC analysis or DC analysis? AC analysis or DC analysis? That's the first thing. Secondly, end of the day, you had to get the gain. Which type of gain it has been asked? The transconducting gain. You had to get the gain GS is equals to of I naught divided by of Vs. Obviously, as we have seen earlier, any sort of gain, whether it's a transresistive, transconductive, voltage or current, it's a type of AC analysis. AC analysis. So whenever you do the AC analysis of the BJT, whenever you do the AC analysis of the BJT, and that too in a small signal low frequency or a small signal mid frequency, definitely the BJT can be replaced with the two different models, either the H parameter model, either the RE parameter model. H parameter model or RE parameter model. May I know which particular model has to be used to smash this problem out? Whether should I use the H parameter model or should I use the value of RE parameter model? RE parameter model. That solely depends on the problem. Which are the different kinds of the data are being supplied along with the problem? Which are the different kinds of the data is being supplied along with the problem? My dear friends, if the value of HI, try to understand in this way, if the value of HI, HFE minimally, or in future HOE or HRE, those datas are supplied along with this problem. So definitely I could have gone with the H parameter model, But at least in this problem, you can see very well the datas which are given along with this problem. What are the datas they have been given? They have given the Boltzmann voltage. Yes, clearly they have been mentioned it. And not only that, even all of the biasing conditions are clearly given, which are the must have condition in case of RE parameter. So you yourself would be able to judge whether should I use the H parameter model or should I use the RE parameter model. H components or the parameters of the H parameter has not been allocated along with the problem, whereas the requirement of RE is clearly supplied along with this problem. So definitely this problem will go with RE model. Agreed? And how the value of R pi as well as R naught has to be calculated? Obviously with the help of DC analysis. Yes. So what I would do? I would just copy this circuit out. Let me copy this circuit. And first I would be calculating the value of R pi as well as R naught. Let me go into the next page. Just a minute. Yes. Just let me focus over this particular part. So let me do that. Yes. Tell me how much exact answer we are getting. Few of the people wanted to have given the formulas how to calculate the value of R pi, but anyways I want to know the exact value of R pi. Tell me what would be the exact value of R pi. My dear friends, anyways, as I have said, you had to go ahead with the DC analysis, and whenever we do the DC analysis, what are the consideration has to be taken care? First, all of the capacitances would become open circuited. Why? Because it would be replaced with its reactance, and keep in mind the reactance offered by the capacitance at low frequency, it's simply equals to infinity. Yes. Not only that, even all of the AC source would be removed. If it is current source, it would be open circuited, and if it is voltage source, it would be short circuited. Yes. So let me do one thing. Let me redraw this circuit. Over here. So what are the changes has to be taken care? So this would become open circuited when I would be doing the DC analysis. Similarly, this would become open circuited. Yes, this would become open circuited. Yes, and even this would also become open circuited. Yes, no? Yes, this would also become open circuited. Anyways, how the R pi is being defined? R pi is being defined. Anyways, the R pi can be calculated with the help of Re. The Re into 1 plus beta. 1 plus beta. Yes. How the Re is being defined? The Re is nothing but Vt divided by of the emitter current IE. Emitter current IE, which has to get multiplied with 1 plus beta. Which has to get multiplied with 1 plus beta. Anyways, at least for this problem, the value of Vt is clearly given. How much it is? The Vt has been given as 26 millivolts. 26 millivolts. And now when we have been taken its DC equivalent, you can see very well the emitter terminal is sinking the amount of current which is precisely equals to of 0.8 milliamperes. 0.8 milliamperes. So here it becomes 0.8 milliamperes. And here 1 plus beta, beta is also supplied along with this problem, which is nothing but 65, which is nothing but 65. So you had to multiply those datas and had to get the first value, and that's nothing but the R pi. R pi 26 millis and millis are getting cancelled out. So simply it's nothing but 26 divided by 0.8, and now it gets multiplied with 66. It gets multiplied with the 66. Tell me exact answer which we are getting, approximately which we are getting is 2.14 kilo ohms. 2.14 kilo ohms. Yes. 2.14 kilo ohms. Similarly, let me focus over the R naught. R naught. How the value of R naught is being calculated? R naught is nothing but the output impedance between collector to emitter, and it's being defined as early voltage divided by of IC. If you want from where this formula have come, I can give a little bit idea about it. My dear friends, when the BJT is in active region, BJT is in active region, earlier it was, yes, now it is in active region. Theoretically speaking, once it goes into the active region, the IC becomes independent from VCE. IC becomes independent from VCE. That's a practical situation. Sorry, theoretical situation, but practically it does not happen. Practically it does not happen. There used to have a little bit dependency of IC over the VCE, and because of that it used to be little bit tapered. It used to be little bit tapered, sort of this. Yes, it used to be little bit tapered. Now if I extrapolate all of the line linearly, so approximately they meet at a certain very large voltage, and that's nothing but VA. We call it early voltage. We call it early voltage. Yes, we call it early voltage. And now if we'll be discussing about the output impedance of the transistor, obviously it would be very same as 1 upon R naught. Why I have taken the reciprocal of R naught? Because the y-axis is being dedicated towards current, whereas the x-axis is being dedicated towards a voltage. So may I know how the R naught is being calculated? That's the change in y divided by change in x. Simply the R naught or 1 upon R naught is change in y, which is nothing but del of IC divided by of del of VCE. So simply you can do one thing. You can take a reference of a certain current IC, it's nothing but the IC, and that's nothing but the value of VCE, which starts from VA. But VA is such a large value, if you add this component towards this component, you will get to know as such there is not much difference within the complete displacement. So this is nothing but the worth of Y, and this can be taken as worth of X, and put together it becomes VA divided by of IC. VA divided by of IC. Yes, VA divided by of IC. Agreed? Know what I am saying? Many of us would have a little bit difficulty, sir. What you are saying, my dear friends, what I am saying, although the VA is looking very near to the origin, but the worth of the VA which you will see practically, the value of VA is how much? 75 volt. And whereas practically collector to emitter voltage across the practical BJT would be in 2 volts, 3 volts or 5 volts. So this is at 75 volts and this is at 1 or 2 volts. So if you will take the complete displacement, so that worth would be VA plus of VC can be approximated as VA itself. So put together, if we will talk about the slope would be linear in nature. Here there is a change in Y component which is simply equals to of IC, the change in X component that simply equals to approximately VA, approximately equals to VA. So easily you would be able to get this slope. The slope is going to be IC divided by VA, which is equals to of 1 upon R naught. So R naught is going to be simply VA divided by IC, VA divided by IC. Yes. May I know what's the VA? VA is clearly given with the problem because it's a process parameter. Once the BJT has been fabricated, you cannot change the value of VA. So here it becomes 75. Here it becomes 75 volts. IC. See, the value of IE is known to me. From IE, I need to get the value of IC. That would be equals to of beta times of IE divided by of 1 plus beta. The 1 plus beta towards the denominator can be shifted towards upside. So here you would be getting the value of R naught. How much it is? It is nothing but 75. The value of beta is known to me, which is nothing but the 65 probably. Let me see that. How much it is? 65 it was. Yes. So here it becomes 66 divided by of 65. Yes. Yes. And here at denominator, IE would come into the picture, which is nothing but 0.8 millis. 0.8 millis. Agreed? And once you will multiply each and individual factors, the component of the result which you would be getting probably, it's nothing but the 95.2. 95.2. You can check by yourself. Kilo ohms. Let me check that. So here 75 into 66 divided by of 65. Yes, divided by of 0.5. Yes. So approximately you would be getting the answer as 95.2. 95.2 VA divided by of IC. VA divided by of IC. Agreed? I can write once again. Just a minute. I can write once again. So here the factor which you will be calculating is simply gonna be, here it becomes 75 gets multiplied 1 plus beta, that's nothing but 66 divided by of 65 into of IE. So the IE is again known to me. The worth which we would be getting is somewhere 95.2 kilo ohms. 95.2 kilo ohms. Yes. Now I would ask one important question. Can I get the gain from this given system? And if I really wanted to get the gain from this given system, what would be my approach? My dear friends, so far I was going behind the value of R pi as well as the value of R naught. But when we were interested finding the gain offered by this given system, which is transconducting gain, which has been the ratio of I naught versus Vs, you had to do its AC analysis. Why? Because the gain is a type of AC parameter. Agreed? No? Whenever you deal with a certain parameter, you had to have one clarity in your thought whether you have been dealing with a DC parameter or the AC parameter. So far, the calculation of R naught was completely based on DC analysis. The calculation of RE, R pi was completely based on DC analysis. So what I would be doing, I would be copying this circuit. Would go into the next page, and now the AC analysis has to be done or has to be made over this circuit. Yes, has to be made over this circuit. May I know how we will apply the AC equivalent over this circuit, So you have to recall what used to be the AC equivalent of the BJT when the input signal is small and the operating frequency is the mid-band operating frequency. You used to have the common terminal towards the input as well as output, and that used to be taken as emitter terminal. And similarly towards the input side, virtually if you have taken the given BJT as a common emitter BJT, so the input would become base, and similarly output would become collector. In between base to emitter, there used to be the effective resistance, which is nothing but R pi, which is already been calculated. Keep in mind, although it is AC model of the BJT, which is also called RE model, but the value of R pi was calculated with the help of DC analysis. And similarly, in between collector to emitter, you would be having the two elements. What are they? You would be having a current dependent current source, which would be beta times of IB. What's the worth of IB over here? The IB is the flow of current which is flowing from base to emitter, and in between collector to emitter you would be having the output impedance, which is equals to of R0. Although most of the time we neglect R0, we keep R0 as infinity. So by default this problem becomes a very handy problem to deal with, but at least in this problem the value of R0 has been clearly given in terms of VA, and which you have also calculated, agreed? So what we had to do, when the AC analysis has to be done along with this circuit, this BJT has to get replaced with this equivalent AC circuit. And many of the times I have seen the student used to have one doubt, sir, this equivalent circuit, whether it's true for NPN or PNP, my dear friend, it's true for both of the cases. Like we had the equivalent of MOS, which had the VGS had the impact over the current, and similarly we had the RDS that was equally valuable for the NMOS as well as PMOS. The same concept goes with this. So you need not to have any doubt, sir. It is the PMOS, sorry, this is nothing but the PNP transistor. So should I be using the same equivalent or not? Yes, you would be using the same equivalent. Agreed, no? Agreed? Tell me how we will proceed further. So let me do one thing. Let me copy this circuit and bring it to the next working board. Now the AC analysis has to be done. How we will do the AC analysis? Just try to understand in this way. When we do the AC analysis now, few of the important component is already been given. Yes, few of the important component is already been given. See, what are they? First, this would become short circuited. Yes, sir. This would become short circuited. All of the external capacitances would become short circuited, as the operating frequency is at mid frequency. So obviously the reactance offered by each of the capacitance would be almost zero. Yes. Not only that, here also you would be having the same approach. It would become short circuited. Yes, sir. Similarly, this is a DC current source. How did you know that's the DC current source? You can see very well, with respect to time, definitely the worth of I is not going to change. So it's a DC current source. It would be killed or would be replaced with a open circuited path. Yes. Similarly, this capacitance has to become short circuited, which we have been talking about the AC equivalent. The AC equivalent approach would be same, either you go ahead with the MOS or you go ahead with the BJTs. Anyways, the JFET is no more in your syllabus, but in case of JFET also the concept was very same. And similarly, this 5 volt would get grounded, and similarly this 5 volt would also get grounded. Agreed. Now what you had to do, you had to replace this equivalent circuit. In between base to emitter you will be having R pi, in between collector to emitter you will be having R0 as well as beta times of IB. Keep in mind the direction of current would be from collector to emitter, and similarly the direction of current IB would be from base to emitter. So you had to come back and you had to watch where are the three different terminals. You can see very well, here you had the base, here you had the emitter, here you had the collector, So what I would do, let me rub this out completely so that I can redraw this circuit into the much proper way. Yes. So what it was base. What it was emitter, no, it was emitter. What it was collector. For the better understanding, do one thing, keep those terminals little bit far away, somewhere here. Yes, here I can say emitter. Now you can see very well, in between base to emitter, there would be a resistance which we have seen, that is nothing but the R pi. The value of R pi is already been calculated. Yes, there would be a flow of current IB from base to emitter. So here goes the current IB. Here goes the current IB. Yes, sir. And you can see very well the emitter is clearly grounded. How? It was getting a short circuited path from the capacitance and even the DC source getting ground. So definitely it became grounded. It became grounded. If you want, you can redraw this circuit. But probably if you are well acquainted with the networks, probably you would be able to smash this problem out. As such, not a great problem to deal with. No. In between collector to emitter, you would be having the two components. May I know what are they? First, you will be having beta times of IB. You would be having the beta times of IB. How much the worth of the beta has been given along with this problem? The value of beta which is being given along with this problem is nothing but 65 times of IB. 65 times of IB. Yes. And in parallel with this source, we had a collector to source resistance, and which worth which we have calculated is nothing but the R0. And you can see very well, there was the connection in between this two terminal. So I can do one thing, I can connect them together. Yes. This is the complete circuit. And you wanted to get the ratio between I0 and Vs. My dear friends, do you have any impact of 24.8 kilo? No, 24.8 kilo is in parallel Vs. So if the potential across this terminal is Vs, the same potential will prevail across this 24.8 kilo. So for the time being, you can just keep aside this factor 24.8 kilo. Yes, my dear friends. Now tell me, how will you calculate the value of I0 versus Vs? My dear friends, Vs can be easily calculated in terms of IB. If you'll apply a loop which has been started from a ground, you have gone through this path, and again you have reached to ground. If you want, I can apply a KVL path across it. Here it starts from this path, goes till this. Obviously, you have started from ground, reach to ground. It strikes the minus terminal of the Vs, which is simply equals to of minus Vs, plus of R pi. R pi is sinking the amount of current, which is simply equals to of IB, and here it goes plus of 0 is equals to of 0. So Vs can be simply written as R pi into IB. Yes. Now, with the help of certain KVL or KCL, if I would be able to write the value of IB in terms of I0, no, that means if IB could have been written in terms of I0, easily I could have found the ratio between I0 and Vs. And the ratio between the I0 and Vs is nothing but the effective transconductive amplification offered by this system. Agreed? So what I would be doing? I would be using a certain KVL and KCLs towards the output side. May I know what would be that? Tell me, what would be that? You have started from 0 and you have come to 0. Tell me, what would be the approach which you will be using over here? What's the approach which you would be using over here? So what I would be doing, I would be just copying this circuit as it is. But the direction I would be making it reverse. So this terminal would come over here and this terminal have come towards downside. That means all four elements would come in parallel. Anyways, focus over the V0 first. What are the elements we had? We had 4 kilo. We had 2.54 kilo. 54 kilo, and the amount of current I0 which we are observing, that we are observing across the 4 kilo only. So nobody should have any confusion, at least at that point. Nobody should say that the current which has been carried by the 2.54 as well as 4 kilo is the current I0. No, the I0 is exclusively carried by 4 kilo. For the better understanding, even you can do one thing. You can write this is the current I0. Yes. And now this terminal has been taken towards this side. So here even the R0 would come. Yes. And here the direction would be from this terminal towards the ground, and that's nothing but 65 times of IB. 65 times of IB, yes, 65 times of IB. Now easily you would be able to get the relationship between IB as well as I naught. First of all, the direction of I naught is from top to down, on whereas the current which has been sourced to this particular circuit is having the direction towards downside. So 65 times of IB can be written as minus 65 times of IB, and now the direction would be towards right hand side. So what I would be doing over here? So I would just be reversing the direction of current, and simply it would become minus 65 times of IB. Minus 65 times of IB. Now you can take the parallel combination of R naught and 2.54 kilo ohms. For the time being, why don't we take this as R1? Why don't we take this as R1? Anyways, the value of R naught is already been calculated, which is nothing but 95.2 kilo ohms. It's such a large value. Approximately, if you'll take its parallel combination, the parallel combination will remain almost same as 2.54. But anyways, you had to calculate this precisely. And from here, you will get to know minus, sorry, just a minute. Here, the I naught would be equals to, from the current divisor rule, you had to calculate the current across the 4 kilo. So definitely at numerator, the component of the resistance would be the parallel combination of both of them. That's simply equals to of R1 divided by of R1 plus of 4 kilo, and which would be multiplied with minus 65 times of IB. Minus 65 times of IB. Yes, my dear friends. And from here, you can get the value of IB in terms of I naught. Each and individual factor would get shifted towards right hand side. So here you will be getting minus times of a certain constant into of I naught. Yes. Agreed? Obviously, no, the C you can calculate by yourself. The value of R1 is known. Each and everything is known to me. So simply I would be placing this value over here. So here it becomes Vs is equals to R pi, which is already been calculated. Next, it's IB. The IB is equals to of minus C, that's a constant, times of I naught. So easily you would be able to get the transconducting gain, that's the Zs, is equals to of minus C R pi. Yes. And the answer which I have calculated and which I am getting is simply equals to of minus 11.6 milli. Obviously the unit would be MOS, which is ampere per volt. Yes, ampere per volt. Could you understand what I am saying? My dear friends, would you agree or not that even I do not know, but nowadays, at least in electronics and instrumentation, such a heavy problems are repeatedly coming. Although that's a different matter together, they may not ask you to get the value of Re as well as R naught. Even they might have been given along with the problem, but yes, they may ask to find the gain, which is nothing but the ratio between I naught to Vs. Yes. So what would be your procedure? First get the value of Re, then get the value of R pi, then get the value of R naught. Anyways, those data are clearly known how to calculate that. But yes, Re, R pi, R naught, they had to get calculated while DC analysis of the given BJT. That's the first thing. Next, as I was interested finding the gain of the given system, either any type of gain it is, the BJT has to get replaced with its equivalent circuit. So what I did, I replaced it. But the replacement must be so smooth. I know many of the times the student do what replacement, but end of the day they are not able to calculate even the gain itself. My dear friends, if you are well acquainted with the network theory now, probably you would be able to smash this problem easily. What was my agenda? My agenda was to get connected the I naught as well as Vs. Anyways, here if it becomes grounded, so whatever the KVL you take, no, that KVL has to get stopped to till this point. So you can do that. No, simply you can say the Vs is very same as the voltage drop across the R pi, which is nothing but the R pi into IB. That is what this. Now, as we were interested finding the ratio between the I naught as Vs, so why don't we keep a certain situation where the IB would become a function of I naught. So in future you can get the ratio of I naught as well as Vs. So what I tried certain KVL and KCL towards the output side. Now again, many of us would have one doubt, they may take a KCL over here. Don't do that, no. Unnecessarily you are taking a KCL over here. This complete structure has been taken towards the downside. This is also grounded, this is also grounded. That means all of the 4 elements have come in parallel. All of the 4 elements have come into the parallel. The direction should be very clear to all of us. The direction is coming down. That means in future, if you had to reverse this direction, it would become minus 65 times of IB. Then only there would be a source of current from top to bottom, and that is what has happened. That is what has happened. And now the answer which we are getting is simply equals to of minus 11.6 milliampere per volt. Minus 11.6 milliampere per volt. Yes. So what's going to be the bestmost answer? The bestmost answer which we are getting for this problem is option B. Is option B. Is option B. The B is going to be the bestmost answer. B is going to be the bestmost answer. Now, the next question which I am going to take, the straight question have come in gate examination, but this is such an important problem. I have just copied a problem from the gate examination. Gate examination. Again, this problem is the problem from the concept of MOS. Concept of MOS. Let me read the problem carefully. What the problem states. The problem says, in the circuit shown, the threshold voltage of PMOS mod of VTP. Why? Because if you talk about the threshold of the PMOS, it used to be in negative. That is why the mod has been taken. And NMOS, which is always positive, which is VTN, transistor both are equals to 1. What does that mean of it? That means the pure value of VTP is minus 1, and at the same time the value of VTN is 1. All the transistors have the same output resistance RDS of 6 mega ohms. 6 mega ohms. The other parameters are listed below. Yes, the process parameters are clearly given along with this problem. That's nothing but the mobility of the N inverting channel, that's a mu N into COX, that's a oxide layer capacitance per unit area, that simply equals to 60 microampere per volt square. W by L ratio of NMOS is 5. Similarly, mu P COX is 30 microampere per volt square, and similarly W by L ratio of PMOS is 10. PMOS is 10. Yes? Yes, no? Now many of us would think, sir, why this factor is higher and why this factor is lesser? You can refer the concept of devices. The mobility of the electron is at higher side in compare with the hole. That is why this factor is towards higher side and this factor is towards lower side. Anyways, I do not have that much time to discuss each and individual data. But deliberately what they have done, do you know that? Although this might have been 60, this might have been 30, but the multiplication of mu and COX along with its W by L ratio is precisely equals to of 60 into 5, that's nothing but the 300 microampere per volt square, and here 30 and 10, again it is 300 microampere per volt square. Deliberately they have kept the same value of mu and COX W by L ratio, or you can say mu COX W by L ratio for the NMOS as well as PMOS, because in future whenever mu and COX comes, it comes along with the W by L ratio. Whenever the mu P COX comes, it comes along with its W by L ratio. That means you can say the worth of mu COX W by L is same for PMOS as well as NMOS. PMOS as well as NMOS. Yes. You can see. Now, the channel length modulation and body effect has to be neglected. You had to get the ratio between the output voltage versus the input voltage, and has to be rounded off. Has to be rounded off. Till how many decimals? Till how many decimals? Where? 1 decimal. 1 decimal. Anyways, before starting this problem, I would like to take the concurrence. How many of us would be able to solve this problem? Probably this was the problem from gate electronics, maybe 2020 or 2019, exactly I am not able to remember. It's a straight problem from the gate. Deliberately I have brought this problem such that I would be able to at least connect you guys that this sort of problem are repeatedly been coming in your gate examination. It's been coming in your gate examination. Tell me, how will you approach with this problem? How will you approach with this problem? Again I am saying I am not going to spend much amount of time over this problem. with the help of short tricks and with the help of certain assumptions, easily we would be able to crack this problem out. Tell me. Let me drink a bit water. Tell me how we will proceed further with this problem. My dear friends, before going into the detailed analysis of this problem, I would like to ask one thing from each one of you, whether we had to do the DC analysis with this problem, whether we had to do the AC analysis with this problem, or whether we had to do both of the analysis, AC as well as DC. Look this problem carefully and then try to conclude whether the DC analysis is required, whether the AC analysis is required, or whether both of the analyses are required for this particular problem. For this particular problem, tell me. Tell me, let me see your comments. Tell me the DC, AC or both. DC, AC or both. Let me see the comments. Yes, the answer have started coming. That's nothing but the minus 900. Yes, very perfect, my dear friends. But still, if you have got the answer minus 900, no, I will give you a little bit simplification how we will approach this problem with the minimalistic number of steps, both AC and DC. Obviously. Why so? My dear friends, try to understand in this way. If you are looking for the gain, obviously, if you are looking for the gain, input impedance, output impedance, at the same time, like power gain, voltage gain, current gain, by default you have been dealing with the AC analysis of this circuit. But while doing the AC analysis of the circuit, you had to replace each of the MOSFETs with its equivalent AC model. And within the AC model, what are the different datas are required? We require GM, that's nothing but the transconductance, and we also require the drain to source resistance, which has been clearly given along with this problem. When the value of RDS is not being supplied along with the problem, no, the problem used to be a comparatively simpler problem, but here the RDS is also being supplied. Anyways, two answers I have seen over. Yes. The two answers we have seen over the live chat. Now both of the students try to observe this problem carefully, how in the simplified manner I would be approaching this problem. How simplified manner I would be approaching this problem. My dear friends, I would ask one more important thing. First, should I use AC analysis? Then I should go for the DC analysis? Or initially I should use the DC equivalent of the circuit and then I should go for the AC equivalent analysis of this circuit. Tell me. First, I should draw its DC equivalent or whether I should draw its AC equivalent. I want the input over the live chat, so at least I'll get to know how far you people are able to grasp the actual concept behind this problem. Tell me. My dear friend, many of us would think, sir, we'll start with the DC analysis of this complete circuit. Why? Because we need to get the value of GM at MOS1, MOS2, MOS3 and MOS4. Why don't we write this as MOS1? Why don't we write this as MOS2, MOS3 and MOS4? But I would say that would be a wrong approach. Why? Because exactly I do not know what are the different values of GM would be needed while calculating output voltage versus input voltage. So first I would be doing the AC analysis. Yes. First I would be doing the AC analysis just to know which are the values of GM are required at least to solve this problem. Agreed? And once we are thorough, this many data of GM are required, then I'll go back and I will do the DC analysis and then I'll be getting those proper values of GM. I'll feed over the gain and thereafter I'll be getting the exact answer. So first I would be doing the AC analysis, then I would be doing the DC analysis. Why so? My dear friends, if you straight jump into the DC analysis, you yourself do not know what are the different values of GM is required to calculate the ratio between output to the input. Yes, I will go ahead with the DC analysis. Try to understand what I am saying. Yes. Next. My dear friends, whenever you are dealing with the MOS based circuit, you must have the clear cut idea. What I am saying, you must have the clear cut idea whether the given MOSes are PMOS or NMOS. Yes, it is PMOS because the bubble is marked over here. PMOS, the bubble have marked over here. PMOS as well as NMOS. Many of the times I have seen, if the students are able to figure it out, sir, yes, it's a PMOS and it's a NMOS, they are not able to figure it out where the source is being lying and where the drain is being lying. My dear friends, keep one thing in your mind, always there would be a flow of current from drain to source in case of NMOS, and there would be a flow of current from source to drain in PMOS. Agreed? So you can see very well, as the current is flowing in this path, and as it is PMOS, definitely it would become your source terminal. Either you can write S1 for referring the source of M1, agreed? Similarly, again it becomes the source terminal 2, yes. If you want, you can write, otherwise you can keep as it is. You can write this as S2. Agreed, no? S1 and S2. Agreed, my dear friends? Yes. Anyways, keep aside, now focus over this MOS. This would be again source, this would be drain, and this would be source now. Just a minute. This would be source now. Where it is? Yes, here it is. This would be source now. Why I am so cautious about the arrows as well as source, my dear friends? Until and unless you do not exactly know where the source is being lying, definitely you would not be able to convert the given MOS into its equivalent circuit. May I know what used to be its equivalent circuit? Even the first problem was based on the same concept. Yes. Where it is? Yes, this has to get replaced, but the replacement has to be done in between drain to source, and even the direction of the current must be from drain to source. What I am saying, from drain to source, that is what I am saying. It is very important to at least visualize where the drain is being lying and where the source is being lying. Yes, although it might be taking time, but the student who are well acquainted with this many important small concepts, they would be able to do the things in the much faster way. Let me go ahead. Let me do one thing. Let me copy this complete figure and bring it to the next working board. And let me just focus over this circuit alone. Yes. This circuit alone. So I would just be focusing over this circuit alone, and I would be applying AC equivalent. See, what would be my approach? First, locate the source terminal. You can see very well, here it is gate terminal, here it is source terminal, which we have already seen. Similarly, here it is the source terminal and here it is the drain terminal. Yes, here it is been a source terminal and here it's been a gate terminal. Drain terminal. Yes, my dear friends, whenever you do the AC analysis, try to understand what I am saying. Whenever you do the AC analysis, all of the external DC sources are being killed. What does it mean of it? Obviously, certain DC biasing voltage would have been applied across this terminal, made grounded. Even this 4 volt would be made grounded. Yes, sir. Would be made grounded. Agreed? And here you can see very well, as I have been telling you again and again, here it's the source terminal, and now you can see very well the gate is getting connected to the left of the circuit. The gate is getting connected to the left of the circuit, and you can see very well towards the left hand side there is no AC signal. We have been dealing with only and only DC signal, which has already been killed. What does it mean of it? That means in AC analysis, the voltage across this terminal is simply equals to 0, which is nothing but the gate terminal of this particular MOS, and the source is already been connected to the ground. What does it mean of it? What does it mean of it? That means the worth of VGS for this particular mask is simply 0. That means the drain to source has to get replaced with the two different elements. First is dependent current source, which used to be GM into VGS. As the VGS became 0, it would just be replaced with the drain to source resistance, which is already known to me. Yes? Yes, no? Agreed what I am saying? This only has to get replaced with RD only. What about this? My dear friends, if we'll talk about the VGS is no more 0. VG is getting connected with the Vin and VS is getting connected with 0. That means there is a substantial potential difference between the gate to source. So here GM VGS, which is a current source, cannot be made 0. So just focus over this. May I know what would be the replacement of this? This would be just equals to of this. This would be just equals to of RDS, and which was simply written as RD, and towards the upside it would get connected with the ground. And similarly, if we'll talk about this, here you would have the replacement. Obviously, sir, I would be having a replacement which would be RD, which was common, RD, and at the same time you would be having GM into VGS. What you would be having? GM into VGS. Which GM I had to use? I had to use the GM of this transistor alone. That is what I am saying. Once you will be doing the AC analysis, you will get to know which GM has to be calculated with the help of DC analysis. And the direction of current is utterly important. The direction of current is from drain to source. So until and unless you do not know where the drain is being lying, where the source is being lying, definitely you would do mistake over the sign. So here it is drain, here it is source, you would be focusing over GM. For the time being, you can write this as a transistor number 1. So here it becomes GM1. What is the VG? S. The VG is being connected with the VN, and similarly VS is being connected with 0, and here it's gonna be simply VS. Yes. I can say such a childish outcome we have got it. The student who would be able to visualize this circuit carefully, like teacher like me or the teachers who have been dealing with the circuit again and again, they themselves at the first look they will be able to know the relationship between V in and the rest of the circuit. There is nothing going out, nothing to do with that. And if we'll talk about this particular MOS, no, it would have only effect of a resistance, because the worth of VGS is simply 0. Yes. So let me do one thing. If you want, I can change this circuit here itself. Otherwise, do one thing. Here it goes like GM1 of VS. This RD would also come over here, and here it becomes RD divided by F2, and exactly at this point, output voltage V0 has been taken. Yes, so this is nothing but the V0. So the V0 is simply gonna be GM1 into VS into RD divided by F2. Anyways, I was discussing about the V0 divided by VS. The direction would be minus. No, why? Because if you want the polarity of V0 positive towards upside, negative towards downside, the flow of current has to be from top to bottom. That means the direction of the current of GM1 VS has to be taken negative, and that is what I have done it over here. Agreed? So simply it becomes minus GM1 into RD divided by F2, where the value of RD is already known. Such a easiest methodology I have used. Again, I am saying, forget about this. Always focus over the AC analysis. Even without changing its equivalent AC analysis, you would be able to analyze this problem here itself. See how. Sir, VGS non-zero. That means there would be a flow of current. Sir, what would be that flow of current? That's nothing but the GM for this particular transistor. Let's take it the GM1 into Vin. Yes, sir, there would be a flow of current across this, and there would be a RD. Sir, yes, there would be a flow of current. There would be a resistance RD. Now, what about the upside transistor? No, sir, there would not be any impact because VGS is simply 0, so simply it would be RD. And now this is also getting connected with the ground. So this can be taken towards this side. Simply it becomes GM4 you can write, GM1 you can write, but you had to be focused about the GM of this particular NMOS. Agreed? You had to just calculate the value of GM4, probably it was. For the time being, I have written 1 over here, 1 over here. May I know what would be your next approach? What would be your next approach? How will you calculate the value of GM? How will you calculate the value of GM? Anyways, how the GM is being defined? GM is being defined as a rate of change in ID with respect to the change in VGS. Anyways, in saturation region, what used to be the equation of ID? When the channel length modulation effect has been neglected, it's simply going to be half times of mu COXW by L ratio. Anyways, at least for this problem, I can write mu n COXY because it's a type of NMOS. So simply, it's a differentiation of half mu n COXW by L ratio VGS minus of VTH. Once you'll differentiate it, 2.5 would went out. It's simply going to be mu n COXW by L ratio. W by L ratio within the bracket VGS minus of VTH. VTH of what? NMOS. I know each and every data. Yes, I know that. Mu n COX into W by L ratio, it's simply equals to of 300 micros. No, keep in mind, it's in micros. Yes, it is in micros. VGS, anyways, the value of VTH, which is equals to of VTN, is simply equals to of 1 volt. Simply equals to of 1 volt. Yes, I had to just focus over the value of VGS, and that too during DC analysis. So let me copy this out. Let me bring it to the next working page. So I am interested finding its VGS. Yes, VGS. How will you get the value of VGS for this particular problem? Tell me. How will you get the value of VGS for this particular problem? Tell me. See, try to understand in this way. They were the identical PMOS circuits. Yes, they were the identical PMOS circuit. Both of them are in saturation region. If somebody will ask why, you can say because their gate and drain terminals were short circuited. Yes, sir. Both will carry the same current. Yes, sir. That is also okay. If both will carry the same current, even the values of VGS or mod of VSG has to be very same. The value of VGS or mod of VSG has to be very same. What does that mean of it? That means here goes my source. This potential, for the time being, I may take this as plus, this as minus. Vx, and similarly this potential, I may take this as plus, this as minus, has to be very same. Could you understand what I am saying? My dear friends, if this current ID is same in both of the terminal, how the current ID is being related? It's a directly function of VGS. If all of the process parameters are very same, in that case, they should have the same potential differences between gate to source terminal. Again, the same thing comes in the picture. Where is the source? Where is the drain? My dear friends, the current sinks in case of PMOS from the source terminal. So obviously it's the source terminal, and here again it's the source terminal. It's a drain terminal. Here is a drain terminal. Agreed? So here it becomes Vx. This is getting connected to this terminal. Again Vx starts. So you can see very well, if you will take a path, 4 volt got distributed in a form of Vx as well as Vx. So simply you can write 4 is equals to of 2 times of Vx, and the Vx is simply equals to of 2 volt. Vx is simply equals to of 2 volt. Agreed? Agreed, my dear friends? So if the Vx is known to be 2 volts, which is the voltage across this, now you got the voltage across this terminal also, Vx. Now the same methodology would be used here also. What it is? The same current has to be processed over here. The same current, yes. The same current has to be processed over here. Anyways, let me write how the DC current ID is being wrote. It's the half times of mu n COX W by L ratio VGS minus of VTH whole square, or simply you can write this as overdrive voltage to the power of 2. Overdrive voltage to the power of 2. Yes. Anyways, if we'll talk about the PMOS and NMOS, they had the differences in mu n and COX, but once we multiplied with the W by L ratio, we got to know both of the MOSes have got the same factor. And if they are carrying the same current, they would have the same overdrive voltage. So I can say the overdrive voltage with PMOS is very same NMOS. The overdrive voltage with PMOS is very same as the overdrive voltage NMOS. Yes. How the overdrive voltage is being written in case of NMOS? It's been written as VGS minus of VTP or VTN, which is equals to of 1 volt, and here it's been written as VSG minus of mod of VTP. Anyways, I am not going into the much detailed part of it. Anyways, both are subtracted, and the value of VSG, what I am saying, the value of VSG is very same as the value of VGS over the NMOS. Here it was the calculation of PMOS, and here it was the calculation of NMOS. May I know what is the VSG? VS is getting connected to the 4 volt. The value of G was same as Vx, which is nothing but 2 volt. So the value of VGSN is to be known to me, and which is nothing but 2 volt. Agreed what I am saying? That is nothing but 2 volt. Yes, so you would be keeping the value of VGS as 2 volt. The VTH is nothing but 1 volt. So definitely this part went out. So the factor which has been left out is simply equals to of minus 300, which is GM. RD, the worth of RD, let me see. What was the worth of RD? RD was 6 and now has to get divided with 2. So here it becomes 1800 divided by 2, and that's nothing but the minus of 900. I know many of us would have taken much amount of time, although I had to explain the each and individual steps with this problem, then only it took such a huge amount of time. But otherwise, if you are well acquainted with the problem related to the MOS, probably you would be able to smash this problem within maybe 2 or 3 minutes. Could you agree what I am saying? You wanted to get the gain, which is AC parameter, but the values of GM has not been given along with this problem. That means the GM has to be calculated. How the GM would be calculated? The GM as well as R0 or RDS has to be calculated using the DC analysis. Now, the 4 different PMOSes or NMOSes we have been using, so exactly I do not know. GM has to be calculated for the M1, M2 or M3 or M4. So why don't we start with the AC analysis just to know what are the values of GM is to be calculated? What are the different values of GM is to be calculated? Yes, so I got to know, just focus over the GM of the 4th transistor. Now I went back and I started doing the DC analysis. And in DC analysis, my focus was very precise and clear. I was focusing over the calculation of GM4 or GM1. So again, I went into the DC analysis, and while doing the DC analysis also, so many steps I have reduced. May I know how I did that? My dear friends, if both of them are carrying the same current, then from the current governing rule, both of them have got the same multiplier factor. That means the value of VGS, anyways in case of PMOS, the value of VSG has to be very same. What does that mean of it? This is what my source and this is what my gate. This is what my source and this is what my gate. Here it has been taken as Vx, here it has been taken as Vx. So if you'll see, obviously it's gonna be 2 times of Vx, which would be equals to a 4 volt. The value of Vx was got to be Vx is equals to of 2 volt. Once you know this as 2 volt, in future even this current and this current is gonna be same. And deliberately what they have done, do you know? Although there was a differences between the multiplication between mu n and COX, but deliberately they kept the value of W by L ratio in such that their complete multiplication is very same. And now you can see very well the overdrive voltage would be same here as well as here, or you can say here the VGS would be very same as the value of VSG, and we know each and everything, and we got the answer. Just wanted to know, could you understand what exactly I wanted to communicate over this problem? Could you understand? If each one of us could understand, so just tell me yes. So at least I'll get the energy. Already it's 12 o'clock. So at least I'll get to know that you guys are understanding what exactly what I wanted to communicate. Tell me. Tell me. And thereafter I would be taking the fifth question. Thereafter I would be taking the fifth question. Tell me. Yes, no? Okay, okay. Let me go into the next question, and this is gonna be the question number 5. Clear, no? Clear, clear, clear. So let me go into the fifth question. Let me go into the fifth question. Here goes my fifth question. Yes. Read this problem carefully. Although I would not spend much amount of time over this problem, but yes, it is again a not tough problem, but yes, it's a well designed problem. It's a well designed problem. Let me see what the problem exactly indicates. The Schmitt trigger, it has been clearly given, otherwise most of the time they would not even write that the circuit through which you have been dealing the problem, it's a type of Schmitt trigger. But anyways, in this problem I have clearly given it's a type of Schmitt trigger circuit, is shown in the above figure. Now it's a below figure. The tripping point for the increasing input voltage would be, yes, input voltage would be, it's a numerical answer type of problem. Anyways, this statement does not make much sense, but it would be your homework. It would be a homework. Analyze the tripping point when the input was decreasing. Although the problem, I had to just focus over the tripping point when the input voltage increases, but you also had to do in your homework as when it decreases, as when it decreases. Yes. Tell me, what would be your answer? Tell me what would be your answer? Tell me what would be your answer? Again, next 1 minute would be offered to all of you. Try by yourself and then I would come in between. Tell me, what would be the best most answer for this given problem? So the answer have started coming. The answer which have come is 0.193. Anyone else apart from this? Anand Garg is asking one doubt, sir, how the gate voltage was 0? My dear friend, why the gate voltage was 0? Just try to understand. Probably this is the point where you would have doubt. How the gate potential became 0? My dear friends, this voltage is just coming because of this part of the circuit. This part of the circuit, and this part of the circuit is purely connected with the DC sources. And if all of the DC sources has been killed, because we are going to do its AC analysis, definitely nowhere at any moment of time or at any moment of point the voltage would be non-zero. Everywhere it would be 0. Everywhere it would be 0, including the gate of this PMOS. That is why it has been taken 0. That is why it has been taken 0. Anyways, come back. Anyways, come back. Tell me, what would be your approach? What would be your approach? Just wanted to ask, or I can just wanted to take a suggestion. Should I go bit faster or the speed is okay? If you want to increase the speed, you can just write I, or if it is okay, you can just write okay. I or okay. If you want to increase the speed, I can go ahead with the faster speed, just write I, or the speed is okay, you can just write okay. You can just write okay. Tell me. My dear friends, just try to understand what exactly in this problem has been asked. My dear friends, whenever you come across increasing or decreasing wording What I am saying, whenever you come across the increasing or decreasing wording over the Schmitt trigger, you should have at least idea about the hysteresis loop, whether it is type of a standard hysteresis loop or whether it is a type of inverting hysteresis loop. Obviously, it would be a type of inverting hysteresis loop. Why? Because the input is being applied across the inverting terminal. May I know how used to be the hysteresis loop? How used to be hysteresis loop in case of standard form as well as inverting form? As well as inverting form. So, you can see very well in case of, just a minute, in case of standard form, this used to be the hysteresis loop, yes. And similarly, in case of inverting form, this used to be the hysteresis loop, yes. If exactly I mark their direction, the direction would be sort of this, Here it is my UTP, and similarly when the output voltage has to switch from plus Vset to minus Vset, all the way it has to come till the LTP, yes sir, agree sir, no issue as such. Similarly, if we discuss with the inverting hysteresis loop, changing the voltage from plus Vset to minus Vset, all the way it has to go till UTP, This is my plus Vset in both of the side, and this is nothing but minus Vset both of the side. And similarly, for changing the output voltage from minus Vset to plus Vset, all the way the input voltage has to go down lower than the value of LTP. Agreed? Agreed, no? Now, I would like to ask one thing. For this particular circuit, which particular hysteresis loop is suitable? The first one or the second one? It's nothing but the standard hysteresis loop, and this is nothing but the inverting hysteresis loop. Yes, tell me. I know this is the point where most of us would be trapped. Which one would be the suitable hysteresis curve for this given problem? Obviously the second one. Why? Many of us would have the doubt, why sir? Whenever the input is applied across the inverting terminal of the Schmitt trigger, by default the output of the hysteresis loop used to be inverting in nature, and wherever the input is being applied towards the non-inverting terminal of the operational amplifier, the output used to be a standard form of the hysteresis. Yes. Anyways, I am not going into the detailed analysis of the hysteresis loop because it is a utterly important topic. So just focus over the important points. My dear friends, what it says, the Schmitt trigger circuit shown in figure, the tripping point for the increasing input. So obviously you have to put this thing in your mind. In increasing input, what does it mean of it? The input voltage is increasing. Once you'll recall what was your x-axis, what was your y-axis. The y-axis was the output from the Schmitt trigger. The x-axis was the input axis. So you can see very well, as you are moving towards right hand side, the input is keep increasing. And as the input is keep increasing, definitely the tripping point which is supposed to come into the picture, it's nothing but the UTP. And may I know, at UTP, the output voltage will change from where to where. That is also very important. Like when the input voltage is increasing, no, in case of standard hysteresis loop, the output voltage is changing from minus Vset to plus Vset, whereas in inverting Schmitt trigger, the output voltage is changing from plus Vset to minus Vset. That means the past voltage or the past output voltage was plus Vset. So you can see very well. If you have been discussing about the increasing tripping point, you have been discussing about UTP. And in case of inverting hysteresis loop, basically you have been sitting at plus Vset and you wanted to go towards minus Vset. That means all of the calculation across the output voltage would be taken place taking the reference of plus Vset. Yes, no? Now, what is plus Vset? You can see very well. That means you can see very well the input threshold voltages or input saturation voltages which has been applied across the operation amplifier is simply plus 10 and minus 10, and you can see very well, if you wanted to calculate the value of UTP, you had to have the value of V0 settled at plus Vset, which is nothing but plus 10 volt. That means all of the calculation would be made taking the output voltage from the operational amplifier as plus 10 volt. Any of the student who have taken the reference of minus 10 volt, they would do mistake. This would have been the case if this would have been a standard form of the Schmitt trigger, and you can see very well when it is increasing, the output voltage switches from minus Vset to plus Vset. That means the state of condition of the output before switching was at minus 10. So definitely the reference of output voltage has to be taken as plus 10. Agreed? Agreed? Now, if the output voltage from the operational amplifier has been saturated at plus 10 volt, try to understand what I am saying, at 10 volt. So what is happening over here? This becomes 10 volt, this becomes 10 volt, and now you can see very well this 10 volt and this 10 volt would try to keep this diode into the forward bias, but straight away you should not assume whether the diode is in forward bias or reverse bias. You had to apply the open circuit test along with this diode, then only you will come across the situation that diode have gone into the forward region. So what you will be doing, here it becomes 47 kilo, here it becomes 1 kilo, here it becomes 10 volt, similarly here it becomes 10 kilo, and here it is nothing but 10 volt, yes, this one and this one 10 volt. And now you would be performing a open circuit test along the diode, and you will be calculating the voltage across this terminal VA. And once you will calculate the voltage across this terminal VA, now you will get to know the value of VA is greater than 0.7 volt. 0.7 volt. What does that mean of it? That means you need not to worry about this diode is on, and if the diode is on, by default you can replace this diode with a battery of 0.7 volt, So let me do that. So here it is just been replaced with the battery of 0.7 volt. Nobody should do any mistake, no. It has to get replaced with a 0.7. Yes. So easily you would be able to get the value of V plus. May I know what would be the value of V plus? Easily you would be able to get. See, the V plus is gonna be V plus minus of 10 divided by 47, V plus minus of 0.7 divided by 1 kilo. Let me do that. So here it becomes V plus minus of 10 divided by a 47 plus of V plus minus of 0.7 divided by 1 kilo. Anyways, the kilo got transferred and it became 0. And being an ideal operational amplifier, it would not sink any amount of current. So easily you would be able to get the value of V plus. Tell me exactly how much V plus we are getting. So here probably I would be getting V plus, 1 gets multiplied with the minus 10 remains same. Here it becomes 47 times of V plus, and here it becomes minus 0.7 into 47. Let me see how much it's coming. Here it's coming 47 into of 0.7, and which is equals to of 32.9. 32.9 is equals to 0. So here it becomes 48 volt. So V plus is simply gonna be minus becomes plus now 42.9 divided by of 48. So here it becomes 42.9 divided by a 48. So the value which we are getting is somewhere 0.89. Yes, 0.89. Now, if you wanted to transfer, you can see very well when the output was kept at plus Vset, at that moment of time the value of V plus was kept at 0.893. Yes. And now if you wanted to toggle this output from plus Vset to minus Vset, the value of V plus should become lesser than the value of V minus. And may I know what's the V minus over here? The V minus is simply equals to of V in. So I can say as the value of V in goes just above the 0.893 volt, there the tripping would take place from where to where? Plus Vset to minus Vset. Agreed? Agreed, my dear friends? Deliberately I did not ask you guys to draw its hysteresis loop, because once I'll ask to draw the hysteresis loop, no, most of us are well acquainted and they'll straight away jump into the UTP as well as LTP and they'll try to get the answer. But if they are precisely asking the tripping point while increasing or decreasing, you had to have the clear-cut idea whether you have been dealing with the inverting form or whether it is a standard form. In case of standard form, the complete calculation would have been very different. You could have taken the output as -10, the calculation would have been very different. So the Schmitt trigger circuit is on the tripping point of the increasing voltage. Obviously here the value of V in would be, how much it is, 0.89, and as the V in goes beyond 0.89, dhadam, there would be a abrupt change of output voltage from plus V set, which is nothing but +10 for this problem, to -10 to -10. Anyways, could you understand this concept? If it is understood, just write here so that I may move ahead with the next problem. Yes. So let me go into the next question. Here goes my sixth question. Where it is? Here it is. The student who have studied improved super diode or fast half wave rectifier probably would be able to smash this problem easily. And yes, consider the circuit shown below. Anyways, let me zoom this problem a bit, just a minute. See what the problem indicates exactly. Consider the circuit shown below. Assume diodes and op-amps are practical diode with the cut-in of 0.7 and op-amp is ideal with the infinite open loop gain. That means in future whenever the diode goes into the forward bias, there would be a drop of 0.7, obviously positive towards anode and negative towards cathode, and the op-amp is being taken as ideal. That means all of the parameters which has been possessed by the operational amplifier has been taken as ideal. The plot of the transfer characteristic for this particular problem, would be, you can see very well, it is a transfer characteristic. What does it mean by the transfer characteristic? Transfer characteristic is a graphical curve which connects the output versus input. You can see very well, output versus input. Output could be in a form of voltage, input could be in a form of current. Similarly, output could be in a form of current, input could be in a form of voltage, or the output could be in a form of voltage as well as the input could be in a form of voltage. So many of us used to have one doubt that the y-axis would always be dedicated towards voltage as well as x would be always dedicated towards the voltage. No, my dear friends, even the transfer function may also have the current as well as voltage relationship. Yes, transconducting or transresisting. So far the problem related to that concept have not come, but probably they may design those sort of problems also. Tell me, what would be the best most answer for this particular problem? So the answer have started coming. So one answer have come as C. The answer have been given by Tridek Majumdar. Anyone else apart from this? Tell me. Anyone else apart from this? See, whenever you come across this situation, no, I would suggest one thing. Anyways, let me copy this out first. Let me bring it to the next page. Focus over this circuit alone. So let me crop a bit. I'm just focusing over this circuit alone. Yes. And probably within 1 minute you would be able to solve this problem out. See, what would be your approach? Let me expand a bit. My dear friends, Anyways, whenever within the circuit, if you get the juggleries of the resistances and the voltage source, I would recommend always use Norton theorem or Thevenin theorem. Anyways, if you have been dealing with the voltages, definitely the Thevenin theorem would be the agreed. So what I am saying, you can just apply the Thevenin theorem towards the left hand side of this circuit, and obviously you can apply because it is being containing only and only linear elements. So definitely the complete circuit which contains the two number of resistance, one number of voltage source would get converted in a form of one voltage source and one resistance. So here VTH and RTH has to be calculated. Being ideal operational amplifier, it is not going to sink any amount of current. So may I know what would be the VTH over here? So simply you can apply the KCL at this particular point, which would be V plus in future. So VTH minus 0 divided by a 5 kilo. Similarly, here it becomes VTH minus and minus becomes 15, minus of minus 15, that would become 15 divided by of 10 kilo is equals to 0. Yes. Rather taking the LCM straight away, what I would suggest, 5k can be taken common and can be brought it towards right hand side and would get multiplied with 0 and become 0, would become 0. So simply it becomes VTH plus of 15 divided by f2 is equals to 0, This 2 gets multiplied with the VTH, 2 VTH plus VTH, that would become 3 VTH is equals to of minus 15. So the worth of VTH would be equals to of minus 5. Now I would ask one more important thing, whether really we want to calculate the RTH or the calculation of RTH is not needed. No, not at all needed. If you are calculating the RTH unnecessarily, you are wasting your time. Why? Because if the complete circuit has been replaced with the RTH as well as VTH, this non-inverting terminal is not going to sink any amount of current. That means there would not be any drop across the RTH. The same VTH would become V plus. So why unnecessarily you are calculating the value of RTH? If you are doing, I am not saying you are doing wrong, but yes, unnecessarily you are wasting your time. Yes. So straight away what I would be doing, just copy this out over here. Let me rub this out. Simply you write this as minus 5 volt, that's it, minus 5 volt. Such a easy problem it became. Yes, minus 5 volt. Agreed? Now what I would be doing, so far I do not know exact states of D1 and D2. So always we start taking, okay sir, for the time being I have taken the D1 and D2, both are off, and according to the value of Vx, which is just taken from the output of the operational amplifier, I would be deciding whether the D1 would conduct or whether the D2 would conduct. Yes. Now one more important thing. Now the polarity of the output, would it be positive or would it be negative, that solely depends on its differential voltage. Agreed? Now you can see very well, if D1 and D2 both are off, there is no feedback, and if there is no feedback, obviously there would not be any flow of current across the 5 kilo. Yes, the 5 kilo current either would flow through the D1 or either will flow through the D2. And if I have assumed the D1 and D2 both are off, definitely 5 kilo would not sink any amount of current. This V in straight away comes across the inverting terminal. Yes. So the polarity of Vx, would it be positive or would it be negative, solely depends on the potential differences between V minus and V plus. Let's do one thing. I have taken the first situation. V in is lesser than minus 5 volt. What does it mean of it? The V in is connected with V minus is lesser than minus 5 volt, like you can have minus 6, minus 7, minus 8. So by default you can see very well, that means the condition which is getting satisfied is nothing but V plus is greater than V minus, and if the V plus is greater than V minus, no feedback as such, that means the output would try to get saturated towards a very higher output voltage. Why? Because if there is no feedback, the voltage difference would get the gain of AOL, which would be infinitely very large. So obviously the Vx would try to go towards a positive infinity. Vx would try to go towards a positive infinity. It would go towards a positive infinity provided I have assumed the d1 and d2 is off, but it's not the case. As the Vx would go towards a positive infinity, what would happen? The d2 would conduct. D2 would conduct. And may I know what would be the equivalent circuit? Let me draw this out. So here it becomes minus, here it becomes plus, here it becomes minus of 5, here it goes 5 kilo, here it comes V in, here it comes V in. The D1 obviously it's non-conducting in state, and here it goes 5 kilo, and it would get conducted. And obviously there would be a potential drop of 0.7, yes. There would be a potential drop of 0.7. Now can you tell me what would be the exact output voltage V0? What would be the exact output voltage V0? My dear friends, you can apply the superposition theorem. Why? Because you have got the two different inputs. First input, obviously it can, my dear friends, it can. So here the minus 5 would get the gain of 1 plus Rf by R1, and similarly V in would get the gain of minus Rf by R1, a standard inverting as well as non-inverting amplifier. So the V0 is simply gonna be, the V in would get the gain of minus Rf by R1, which is simply equals to minus 1, and similarly minus 5 would get the gain of 1 plus Rf by R1, simply I can write this as 2. So here it becomes minus V in, minus of 10, yes. So when the V in is lesser than minus 5 volt, the V0 or the governing output voltage V0 would be equals to minus V in minus of 10, yes. Let me do one thing, let me go into the another side of the story. Now if V in went beyond minus 5, now you yourself would be able to calculate so many things, my dear friends. Now I am not saying you had to calculate each and everything again and again, my dear friends. See what is happening over here. Now this D2, initially if you'll say the D2 was on, D1 was off, but now the situation would be just reversed. So may I know what would be the situation now, you can say? What would be the situation? So the situation would be like, let me do that. So here the situation would be minus, plus, here it goes 5 kilo, here it goes 5 kilo, here it comes V in, here it is still minus 5 volt, and now you can see this becomes 0.7 volt, here comes 5 kilo, yes, here comes 5 kilo, and here the output voltage V0 has to be taken. Now many of us would find little bit confusing, many of us may also write, sir, 5 kilo is not carrying any amount of current, that means voltage across this terminal and voltage across this terminal would be very same, so the V0 would become 0.7. No, my dear friends, the another side of 0.7 is not being connected with the ground, so you can't say the absolute value of this terminal is 0.7, so nobody should write V0 as a 0.7. So what's going to be the V0? Obviously this terminal potential can be calculated taking the reference of this. The virtual ground concept is true. Why? Because there is an intactment of the negative feedback. So if this is minus 5, this would be minus 5, this would also be minus 5. So the equation or the governing equations which we had is simply going to be V0 is equals to of minus V in minus of 10, provided V in is lesser than minus 5. And similarly minus 5 when V in is greater than minus 5. Yes. So easily now we have come to the situation where I would be able to draw its transfer function. How we will do that? So here goes the input voltage which has been applied across the inverting terminal, and here goes the output. The reference voltage has to be taken in terms of minus 5. So let me do that. So reference voltage is being somewhere here, just a minute, is being somewhere here, and that's nothing but minus 5 volt. Yes, it's nothing but minus 5 volt, minus 5 volt. Before minus 5 volt, the governing equation is going to be minus V in minus of 10, minus V in minus of 10. And you can see very well what's the slope of this. The slope is simply going to be minus of 1. And once we'll keep V in is equals to of minus 10, which would come somewhere here, the magnitude of V naught would simply become 0. So you can do one thing, no? You can do one thing, yes. You can draw a straight line, which would be sort of this, yes. And exactly at V in is equals to of minus 5, you can see minus of minus 5 that becomes plus 5, minus of 10 that becomes minus 5, and from minus 5 onwards it simply stucks at minus 5 volt, minus 5 volt. This is minus 10 volt, the slope is minus 1, the slope is minus 1, yes. So if we'll discuss about the best most answer for this given problem, obviously the answer was C. Obviously the answer was C. One more important thing. This could not be the answer. This cannot be the answer. Why, my dear friends? Because the input is being applied across the inverting terminal. So in future, if you will take the relationship between the output to the input, the ratio would always come with the negative sign. Or I can say the ratio between the output to the input would always be negative. That means the straight line which is connecting the ratio between output to the input or slope would always be negative. You can see very well here after 5 the slope was raising. That can happen if the V in could have been applied across the non-inverting terminal. So obviously A has been ruled out at any case. Even D has been ruled out for the any case. The B as well as C was the option. Even if you'll analyze beyond further now, you can also see even the B cannot be the option at all. Anyways, that would be up to you. I need not to go into that detailed analysis, at least before gate examination. So just wanted to know from each one of you, is this part clear to all of us? If it is clear, just write clear. So at least I'll have the fair idea that yes, you guys could have understood the basic concept. Yes. Let me go forward. And probably the question which I would be taking is question number 7. Yeah, it is comparatively tougher problem, but yes, we would be able to manage this problem. 7, where it is, here it is. Not exact, but yes, almost same sort of problem have come once in gate electronics. This problem is the problem from rectangular wave generator or istable multivibrator or relaxation type of oscillator. So probably the student who have gone through the PYQs definitely would be able to relate what exactly we wanted to communicate through this problem. Tell me, an oscillator circuit using ideal op-amp and diodes is shown in figure. The time duration for positive part of the half cycle is being taken as del T1 and for the negative part is being taken as del T2, which is our options are correct. Del T1 is greater than del T2, del T1 is lesser than del T2, output will be regular wave with 50%, rectangular wave with the 50% duty cycle, and del T1 minus of del T2 is equals to of 0.22 RC second, 0.22 seconds. Tell me. Anyways, whenever you deal with this sort of MSQ, no, I would say one thing: try to build up a certain contradictory relationship, like we do in aptitude. See, if output has the duty cycle of the 50%, that means the on period time is very same as off period time. That means in future, if you could figure it out that yes sir, duty cycle is 50%, by default option A, option B and option D becomes 0. Option A says the on time is greater than off time, B says just reversed, and D says there is a certain differences which can be written in this form. So that is what I used to say. Whenever you have a MSQ sort of problem, no, you used to have a certain contradictory. You used to have certain contradictory so that in future you would not make any mistake. You would do not any mistake. Yes. And I would give a little bit simplified manner whenever you have the problem related to the relaxation oscillator, how to deal with that problem, how to deal with that problem. Agreed. Anyways, let me copy this problem and bring it to the next working board. Yes, I would be focusing over this circuit alone. Tell me what are the answers or what are the options would be the appropriate options or answers for this given problem, Yes. Try to understand in this way. You can see very well it is a type of relaxation oscillator. So the person who have gone through a little bit concepts of the relaxation oscillator would be able to appreciate this concept. So the output would have only two possibilities, plus Vset or minus Vset, which has been clearly provided with the problem. Either it would go to the plus Vset, either it would go to the minus Vset. Yes, that's nothing but the plus 5 and minus 5. So few of the articulations must be remembered to each of us. What it is, try to understand. If the output is plus Vset, and if the output is minus Vset, what are the different consequences this circuit would be facing? Just try to understand in this way. If V output is plus 5 volt, you can see very well this diode would be on. Yes, this diode would be on. Why? Because there is a force of current from anode to cathode, and if this diode is on, you can easily find the value of V plus. May I know what it would be? As it is off, it is on. The voltage V plus is taken in parallel with the 1 kilo. So from the voltage divisor rule, it's simply gonna be 1 kilo plus of 1 kilo plus of 3 kilo. Simply it becomes V plus becomes 5 divided by 4. 5 divided by 4. And many of us, just a minute. Okay. Well done, Mayank. Yes, it's no issue. Go ahead, all the very best. And now here what it becomes, it's becoming minus 5 volt. In case of minus 5 volt, what's happening over here? This diode would be on, this diode would be off. So the voltage divisor rule which would be applied is simply gonna be 1 kilo divided by 1 kilo plus 1 kilo, that would become V plus. So here the V plus would become minus 5 divided by F2. One thing you must have been noticed while deriving the relaxation oscillator, whenever the output is at higher plus Vset, the capacitor charges. Yes, see my dear friends, if this potential is being kept at higher potential in compare with the capacitance, definitely the capacitor would acquire the extra charge and the voltage across the capacitor would increase. So whenever output is being placed at higher potential, the capacitance is always charging. And whenever this becomes negative or towards a lower potential, definitely now the capacitor would provide the excess charge which would get grounded through the minus 5 volt. So obviously the capacitor would start discharge. Agreed? Anyways, lump sum I can draw the voltage across the capacitance. My dear friends, just understand in this way. The range of V plus is from 5 by 4 to the minus 5 by 2. Yes, the value of V plus, the range is in between minus 5 by 2 to 5 by 4. Yes. So even the range of V minus would also be minus 5 by 2 to plus 5 by 4. And you can see very well the V minus is nothing but the voltage across the capacitance. So even the range of capacitance voltage would also be in between minus 5 by 2 to plus 5 by 4. So now try to understand in this way. When the output voltage is at plus Vset, the capacitor would start charging. The capacitor would start charging. Yes, sir. It have start charging. It have start charging. It have start charging. Until which particular voltage it will try to go? Obviously, if the output voltage is kept at plus 5 volt, the capacitor across voltage across the capacitor would try to go towards plus 5 volt. But no, this would not be the case, my dear friends. As the output is at 5 volt, keep in mind the V plus is nothing but 5 divided by a 4 volt, and as the voltage across the capacitance goes beyond 5 divided by a 4 volt, now what would happen? The next sequence would start, and that is what discharging. And may I know, after while discharging, see what I am saying, while charging it will try to go towards a plus 5 volt, and while discharging it will try to go towards a minus 5 volt. But when it is discharging, my dear friends, when it is discharging, again the next tail mark would come into the picture, and that is nothing but the minus 5 by 2. And as the voltage across the capacitor tries to go lower than the minus 5 by 2, again their charging sequence would start. Yes, charging sequence would start. So you can say the voltage traveled from 5 by 4 to minus 5 by 2. This period of time is nothing but T off, where the output V naught is equals to of minus Vset, and similarly this is nothing but T on. Yes, the T on was taken as del of T1 probably, and this has been taken as del of T2 probably. Anyways, before going into the detailed analysis, I would like to ask from each one of you, can you get the value of del T1? Yes, you should get that. The voltage across the capacitance can be easily written as VCT is equals to of VC0 plus of VC infinity minus of, just a minute, VC infinity plus of VC0 minus of VC infinity T divided by tau. May I know, while charging, what would be its VC infinity? Obviously, it will try to get settled at plus 5 volt. Yes. So yes, sir, it will try to get settled at plus 5 volt. Similarly, what is the VC0? It is starting from minus 5 by 2. Yes, sir. That is also fine, sir. What about the VC infinity? That is again known to me, and that's nothing but the 5. That is nothing but 5. And here goes e to the power of minus T divided by tau. Yes. Now we wanted to know the value of del T1. The del T1 is the time taken by the system when the voltage across the capacitance exactly reaches to the 5 by 4. Yes. 5 by 4. Just a minute. 5 by 4. And there, this time would become del of T1. Yes. So now the calculation has to be done, and you have to calculate the value of del of T1. Let me do that. So here it becomes, you can do one thing, this 5, everything goes out. 1 upon 4 minus of 1, that would become minus of 3 by 4. Similarly, here minus of 1, that would become minus 3 divided by of 2. E to the power of minus del T1 divided by of tau. Tau is nothing but RC. Yes, the charging has been taken place through this path, so obviously the RC has to be taken for this path alone. Yes, so easily you would be able to get that probably. Yes, so the del T1 which you would be getting, it's simply gonna be RC of 4 divided by 2. 4 divided by 2, that's simply 2. Yes, del T1 would be simply 2, would be simply 2. Similarly, now it's your turn to get the value of del T2. The each and individual sequences would get opposite. Now you had to take the initial voltage as 5/4, you had to take the final voltage as -5. I have seen many of the times the student do mistakes, final voltage they would keep -5/2. No, my dear friends, the VCT reaches to the -5/2, there the time t becomes del of T2, del of T2, agreed? So from there also it's a ln, no, it's a ln of 2, just a minute. It's the ln of 2, ln of 2. Yes, probably del of T2 what we get, it's probably RC ln of 2.5. Exactly I don't remember, but yes, this you get, this you get. So what are the different answers are correct? What are the different answers are correct? So the question, let me see, yeah, the question, so the B was the correct answer, and even the D was the correct answer. Once you will subtract them together, no, the answer which you are getting is approximately this, You can do that, no, you can do that. So here it becomes RC of del T1 was ln of 5 divided by, that was probably 2.5, no, 2.5 minus of RC of ln of 2. Exactly, even me myself don't remember. So here it becomes ln of 2.5 divided by 2. 2.5 divided by 2. You will get the exact answer. You will get the exact answer. Yes. So here it becomes ln of 2.5 divided by 2. Yes, it's coming same, no? It's coming 0 point of 22 into RC seconds. And now one thing is quite sure. If the on time and off time is not same, the duty cycle cannot be 50%. How the duty cycle is being defined? If you have a rectangular output, the duty cycle is being defined as on time versus off time. What? It's nothing but on time versus off time, which is T on divided by of T, which is equals to of T on plus of T off. T off. Yes, T on divided by of T on plus of T off. And you can see very well there is a disbalances between del T1 and del T2. Obviously, this would be ruled out. So the best most answer which we are getting is nothing but B and D. B and D. One of the most interesting part regarding this, my dear friends, if you'll go into the mathematical aspects, you'll really enjoy this. Although you are traveling from plus 5/4 to the minus 5/2 with the same time constant, and now you have been traveling from minus 5/2 to 5/4 with the same time constant, but the time taken while going from minus 5/2 to minus 5/2 to 5/4 was lesser in compare with 5/4 to minus 5/2, and that's nothing but the nature of exponent. That is why the time constant, when they decide, no, for the increasing, time constant used to be different, and while decreasing, the time constant, the concept of the time constant remains different. So you can see where the speed is more, here the speed is more. That is why it is taking lesser time to reach the same voltage difference, whereas it is taking more time. And many of us used to by heart the formula like, sir, T on is equals to, sir, it's a tau 1 plus beta divided by of 1 minus beta. Each and everything would be of no use if this sort of problem do come. Yes, my dear friends, agreed, no? So again I would say the best most answer were B as well as D. Anyways, let me move ahead. So let me go into the next page. So the next question probably was the, let me see which question I had to take now. I had to take the question number 8 now. Yes, I had to take the question number 8 now. Here goes my question number 8, and probably most of us would be able to smash this problem out. It's a type of MCQ, and the problem is based on regulation, voltage regulation. Yes, focus over this problem. Let me read what the problem exactly it says. The Zener diode in the below figure regulates at 50 volt. What does it mean by the regulates at 50 volt? That means this system has been designed in such a way that there could be the changes in source voltage, there could be the changes in load voltages, but the voltage across the load must be fixed to the 50 volt over range of diode current 5 to 40 milliamperes. So in future I can say the load resistance is a variable in nature. So in future if you will change the value of RL, definitely the current across the RL would change. Why? Because the voltage across the RL is fixed to 50 volt, and in future if the RL is changing, by default the current across the RL would also change. Supply voltage is 200 volt. Supply voltage is 200 volt. Calculate the value of resistance R to allow voltage regulation for the range of load current from 0 to I max, and calculate the maximum load current I max. The 4 different options were given along with this problem. Tell me exactly how much answer we would be getting and which would be the correct most answer for this given problem. Tell me what would be the best most answer for this given problem. Tell me what would be the best most answer for this given problem. My dear friends, whenever the problem do come in gate examination, no, they have the set of pattern. Otherwise, if you really go into the detailed study of the regulation, no, such a huge and such an interesting topic it is. But in gate, only few or the selective problem do come in the gate examination. See, here you can see very well the voltage has been fixed to the 200 volt. And now you can see the current is changing. No, the Zener diode in the below figure regulates at 50 volt. What does that mean of it? That means in future you would be bringing a Zener diode which have the breakdown Zener voltage as 50 volt. Yes, that's fine, sir, no issue. So in future once you will be designing a circuit where the load voltage has to get regulated at 50 volt, that means you will purchase a diode from the market which has the Vz is equals to 50 volt, which we have already done it. The current ranges from 5 to 40 milliamperes of the diode. What does that mean of it? That means the current which can be carried by the Zener diode is in between 5 to 40 milliamperes. May I know what does it mean of it? It's a minimum permissible Zener current such that the Zener remains in the breakdown region, which is nothing but Iz knee, and this is the maximum permissible current the diode can carry along with this. Anyways, both have got the two different fundamentals. If the Zener passes the current more than Iz max, that's done. That diode cannot be used further. That's a different thing together. If the Iz goes lower than the value of Iz knee, the Zener diode would not work into the breakdown region, and the health of the Zener diode would remain safe. That means still the diode is jinda, the diode is live, but the working of the diode would not be into the breakdown region, and hence the voltage across the diode would not be the 50 volt. So anyways, my working region would always be in between Iz knee as well as Iz max. If it goes beyond Iz max, that's it, forget about that diode, you have to replace that diode after certain maintenance. And similarly if Iz goes lower than Iz knee, again voltage across the diode would not be exactly Vz, which is nothing but the Zener voltage, So we had to be in between. So what are the data are being asked? First they have asked to find the value of R. Yes. First they have asked to find the value of R, and they have asked to find the value of I max. Tell me what would be the best most answer? And what would be my approach? Tell me. My dear friends, just understand in this way. When you would have IL is equals to 0, you will have the IL is equals to 0 when the load is open circuited. Yes, when the load is open circuited, whatever the current has been sourced by the 200 volt, no, the complete current has to come across the 50 volt or come across the Zener diode. Now the Zener diode is having a little bit problem, such that if the source current goes beyond the value of Iz max, this diode would burn out. That means when you are removing the RL, IL becomes 0. When the IL becomes 0, the maximum current flows across the Zener diode, and when the maximum current flows across the Zener diode, now the Zener diode is in problem towards its higher value of Iz, which is nothing but Iz max. So I would keep the value of R in such, I repeat, I would keep the value of R in such when if it is open circuited, then only the flow of source current should always be lesser than or equals to of maximum permissible current which the Zener diode can possess or can handle. Agreed? Many of the times this situation do come in our practical life. See what happens? Most of the time, see, this is what your mobile only, no? The mobile, whenever you put the charger with your mobile, the charger supplies a fixed DC voltage to your mobile, probably somewhere 5 volt. Yes. When you remove your charger, nobody do like first they will switch off the main supply and then they will remove the charger. No, simply what they will do, they will just plug out or they will just pluck out their charging port. So the load became absent. And now if your charger is based on the concept of Zener voltage regulator, what would happen if the load is open circuited? I do not have charger nearby. If the charger has been plugged out from your mobile, what would happen? Now you can see the load is open circuited. Now the complete current would be experienced by the diode. And the diode has to be safe. So for that, the appropriate value of R has to be selected. So you can do one thing. If IL becomes 0, the maximum amount of current flows across the Zener diode. So you can say Zener current has to be maximum, or will be maximum, you can say, but that Zener current must be lesser than equals to of its awqad, how much current it can really carry. Yes, so exactly I can say the Iz must be lesser than equals to of maximum capacity of the current which the Zener diode can carry, which is simply equals to of 40 milliampere, Anyways, may I know what would be this current? This would be simply 200 minus of 50 divided by R. 200 minus of 50 divided by R. Yes, this current should always be lesser than equals to of 40 milliampere. Yes, 20 minus of 5, that's going to be 150. 150 divided by R, 40 milli. So here it becomes 150 divided by 40 milli, lesser than equals to of R. Exactly, if I would find this value, it's going to be 150 divided by 40, and here it becomes 3.75. So the value of R has to be greater than equals to of. Keep in mind, practically I would keep the value of R little bit higher only, no? I would not calculate, I would not design any of the circuit at the verge of the calculation. So I would be keeping certain greater than 3.75 such that even the load is open circuited, then also the flow of current which is going through the diode would always be lesser than the value of 40 milliampere. So at least the value of R got to be known, Obviously 2.75 cannot be the answer. If you select the value of R lesser than 3.75, so when the load becomes open circuited, the flow of current across the Zener diode would cross 40 milliampere. Definitely the diode would get damaged. So 2.75 should not be selected, 2.25 should not be selected, probably the 3.75 should not be the answer. Practically you will have the value of R greater than 3.75, maybe somewhere 4, maybe somewhere 4.2. But anyways, the calculation has been done over the verge. Now we had to calculate I max. How much maximum current we can extract for this particular circuit. My dear friends, now the value of R got fixed. What it is? The R has been taken as 3.75 kilos. 3.75 kilos. Yes. And here it's nothing but the 200. 200 would get subtracted with the 50 and it would get divided with the 3.75. So simply it becomes 150 divided by of 3.75. So the amount of current which is flowing is simply going to be 40 milliampere, 40 milliampere. See what is happening over here. The load current, which would be 50 divided by RL, in future if RL is changing, definitely the load current would also change across the load. And now my dear friends, as the load current is increasing, no, what does it mean of it? If the value of RL is suppressed or it has been decreased, the IL current would increase. IL current would increase. My dear friends, try to understand what I am saying exactly. As the value of IL current is increasing, the current which was sourced by the source was fixed, which is equals to 40 milliampere. Now this Zener diode is in problem. Why is it? Why is in problem? Because it requires the minimum permissible current, which is nothing but the knee current. If the current across the Zener diode goes lower than that knee current, by default this Zener diode won't work into the breakdown region. That means out of 40 milliampere, if IL is continuously sinking more and more and more and more amount of current, and after certain value of IL, if the IZ goes lower than the 5 milliampere, keep in mind that's done. So may I know how much maximum load current you can extract? Out of 40, maximum you can extract 35 milli. If you'll go like 36, so only and only 40 minus of 36, 4 milliampere would be left out for the Zener diode, and which is not the actual permissible limit. So you can see very well, it is simply equals to 35 millivolts. It is simply equals to 35 millivolts, which is option B. Agreed, no? Probably this must be clear to all of us. Yes, no? So the B is gonna be best most answer, and whenever you have this sort of problem, no, you had to apply the aptitudinal knowledge over this problem. You would be able to smash all sort of problem. Agreed, no? Again I am saying how the R would be decided. R would be decided such that when the load is open circuited, no, the current across the diode should not be such a large value such that the diode would get damaged. So obviously I would keep the value of R certainly higher than a certain critical value. The critical value got to be known, and which is nothing but the 3.75. Practically I will keep greater than 3.75. I have ruled out A as well as C, but I have picked up B as well as D. Taking the help of 3.75, I got to know when the 40 milliampere is continuously supplied, whatever the load resistance it might be, 40 milliampere was continuously supplied, and as the value of load resistance is getting decreased, definitely more and more current would be sunk by the load. So out of 40 milliampere, if 30 milliamperes what sunk by the load, the 10 milliamperes goes through the diode, definitely, which is within the permissible limit. But as the current goes greater than the value of 35 milliampere, it would come into the big problem. So the range would be sort of this. If it is clear, just write clear over the live chat. So at least I'll have the fair idea that yes, you guys are understanding the basic concept behind the each and individual problem. Yes. So now comes the ninth question. It's a utterly delicious problem, but now it's again having a problem. Visibility is the problem. I could not invert its color. May I know whether it's visible or not? Just tell me whether it's visible or not. Probably it may not be visible, no? It is visible, no? Just wanted to ask whether it's visible or not. If it is not visible, I will give you, no, probably it may not be visible, no? Unnecessarily I could not change its, anyways, let me do one thing. Let me draw this. And options were given. Do one thing, leave about the options and all. Just we will be doing the study of this particular circuit. It is a very well designed problem. So let me draw the circuit itself. See, almost same sort of problem have come into gate examination, but I have changed the problem a bit, and now the intensity of the problem would become very good. 0.5 milliampere. It's a problem of BJT DC biasing. 10 volt, 10 volt, 5 microfarad, 5 microfarad, yes, the data which have been supplied along with this problem, beta is equals to infinity, VBE on is equals to of 0.7 volt, 0.7 volt. Now initially switch was closed, switch was closed, switch was closed. Almost same sort of problem have come, but little bit details I was changed in form of MSQ, but probably that image is not visible over the light board, so I'll keep aside. I'll just focus over this problem, and the complete analysis would be done over this problem itself, over this problem itself. Yes, over this problem itself. It's a 4.3 minus 5 minus 10, 0.55. Okay. At t is equals to 0, what I am doing? The switch was open. Switch was open. I would ask few number of questions from each one of you. You had to reply. You had to reply for each of the answers. Each of the answers. Tell me the first question. At t is equals to of 0 minus. At t is equals to 0 minus. Obviously, it would have been in a steady state and where the switch was closed. At t is equals to of 0 minus. What was the state of the transistor? Whether the BJT was in cutoff region, active region, saturation region. Tell me what was the state of the BJT? That's the first question. That's the first question. What was the state of the BJT? In which state it was? In which state it was? Tell me. In which state it was? My dear friends, just try to understand in this way. At t is equals to 0 minus, obviously it was in the switch on mode and the capacitance was completely getting discharged through this path and having the discharging time constant 0. That means the voltage across the capacitance was also 0. Was also 0. So you can see very well at t is equals to of 0 minus, t is equals to of 0 minus, what reason it was? So you had to analyze this circuit. So here it was 4.3 kilo, here it is minus 10, here it is minus 5, and here it would be VBE, which is plus 0.7 volt, and here the voltage was 0 volt, here the voltage was 0 volt, yes. And now I can ask one important thing, in which mode this BJT was working, in which mode this BJT was working. Because this would be a separate problem and problem has been coming repeatedly just to make you sure that which mode of the operation the BJT has been performed. Tell me in which mode the BJT is working now, in which mode the BJT is working now. So one answer have come in a form of active. May I know how? May I know how? Because in this problem clearly it was given at t is equals to 0, the BJT was in active region. So most of the students have taken that wording as for granted, yes sir, it is in active region. But if that value or that wording has not been given, so what would be your assumption? You had to calculate the actual state of the BJT. How will you do that? How will you do that? So definitely you will apply a KVL. You will apply a KVL. At very beginning you can assume the BJT is in active region, and at last you have to prove really it is in active region. And when we assume the BJT is in active region, definitely I can assume IC is equals to of IE. IC is equals to of IE when the value of beta is very large, and IB can be taken as simply 0. Keep in mind this assumption is only true when we take the BJT is in active region. BJT is in active region. Yes. Yes, the answer have started coming. CB junctions reverse bias. Perfect. So what is happening over here? If we'll talk about this current strikes the minus 5 first. So here it becomes minus 5 plus of 0.7, and here it goes plus of 4.3 kilo into of I minus of 10 is equals to of 0. So here it becomes minus 5, just a minute, plus 5, no, plus 5, don't do mistake. My dear friends, if it is minus upside, so definitely it would be plus downside. So the striking of the current would be plus 5. So minus 10 plus 5 would become minus 5, minus 5 plus of 0.7 would become minus of 4.3, minus of 4.3 would go towards right hand side. The current I would be simply equals to of 1 milliampere. 1 milliampere, agreed? Would be 1 milliampere. And now if it is 1 milliampere, in future if you want to know the voltage drop across the 4.3, it would be plus upside minus downside 4.3 kilo into 1 milli, simply it becomes 4.3 volt, 4.3 volt, agreed? Now easily you would be able to get the voltage across this terminal, which would be 4.3 minus of 10, that is nothing but minus 5.7, minus 5.7, yes, that is nothing but minus 5.7, agreed? Now you can even calculate VCE, what it is, 0 minus of minus 5.7, which is simply equals to of 5.7. VCE could have been written as VCB plus of VBE. VBE on is clearly given in this problem, that's nothing but the 0.7. 5.7 gets subtracted with the 0.7. The worth of VCB was found to be positive, and that to 5 volt. 5 volt. And keep in mind, VCB, the C side is made of N layer, and similarly B side is made of P layer, and you can see very well the plus sign is being connected with the N side and minus sign is being connected towards P side. So obviously the junction of collector to base was reverse biased. Collector to base was reverse biased. So obviously it was in active region. It was in active region. Yes. Anyways, that was given in this problem. That was given in this problem. Now what they have asked, once the switching was done at t is equals to 0, for how long the BJT would held its working operation or working condition into the active region. May I know exactly at t is equals to 0, if the switch will go from on to off state, would it have any change of state? No, it won't. It won't. Why? My dear friends, see, here initially voltage was 0. Now the voltage across this terminal would not change rapidly. But yes, the voltage across this terminal would change. How? Because the capacitor would start charging. And as the capacitor across voltage would start charging, the voltage across this terminal would change. Yes, voltage across this terminal would change. And as the voltage across this terminal would change, after certain voltage, this condition won't be true, and it will go into the saturation region. It will go into the saturation region. Why? Because still VBE is on, and as the VBE is on, by default you can have only and only two situations. First is active and the second is saturation. So just wanted to know after how much amount of time this circuit will go into the saturation region after switching off, or after offing, or after opening this switch. After opening this switch, how much time it will take? I wanted to ask from you guys. Let me copy this and bring it to the next working board. Tell me, how much time we will be taking? Just try to understand in this, my dear friends. I know many of us would have a little bit doubt over here. See what is happening over here. This became open circuited, no? So why don't we remove this? Yes, why don't we remove this? Now what is happening over here? This capacitor is getting connected like this. Yes, this capacitor 50 milli. Yes. Perfect. Now what is happening over here? Could you understand one thing? See, this current came because of the BJT was in active region. May I know how much current it was? You can see very well the current which we calculated was 1 milliampere. And which current it was? It was flowing across the emitter. So the emitter current was 1 milliampere. What I am saying? The emitter current was 1 milliampere. And as we know, IC is equals to of beta divided by of beta times of IE and here it has been clearly given in this problem, beta is tending towards infinity. So if you take its limit, the limit would become 1. So IC is very same as IE. So many of the students, what they do, they deliberately do the mistake. IC would be equals to of IE, which is equals to of 1 milli. So this current has to be 1 milli. No, my dear friends, the current which is just sinking across the collector, no, that should become 1 milliampere. 1 milliampere. Then what is happening over here? The current which was sourced by the 5 volt is simply 0.5 milliampere, and the current which is sinking into the collector is simply 1 milliampere. That means just to satisfy the KCL, the rest of the current should come through the capacitor. Yes, and you can see very well the polarity would become positive over here and negative over here. Positive over here and negative over here. Yes. So now if you'll talk about this is nothing but the voltage across the collector, and this is nothing but the voltage across the base. So if you'll say VCB, you can simply say this voltage. May I know what about this voltage, my dear friends? This current is always 1 milliampere, this current is always 0.5 milliampere. That means a constant current would move across this capacitor. That means this capacitor would charge or will charge linearly. May I know what would be the rate of charging? You can calculate. That's very easy. The voltage across the capacitance, or forget about the voltage, current across the capacitance is IC is equals to C dVc by of dt. So if I'll take the integration both of the sides, so what it would become? It would become IC of t. Similarly, this C can be brought towards left hand side, and simply it would become Vc of t with the arbitrary constant. And now you have an initial condition that initially capacitance was uncharged, so simply you can take that initial voltage or arbitrary constant as 0. So here the VCT became IC. How much it is? 0.5 milli divided by of C. How much it is? 5 micro it is, and here it goes T. May I know what must be the voltage across the capacitor here? What must be the voltage across the capacitor such that so far it was working into the active region, but now it will leave the active region, will go into the saturation region? Tell me what it must be. Obviously, here it is positive, here it is negative. At very beginning, at t is equals to 0, the voltage was 0, and as the t was lapsing, it would become like plus minus 1 volt, plus minus 2 volt, plus minus 3 volt, plus minus 4, plus minus 5, plus minus 6. My dear friends, as the voltage across this goes beyond plus 5, the impact over this terminal would be minus 5. Yes, and as the voltage across this terminal goes beyond 5, the voltage across this terminal would go lesser than minus 5. Yes, would go lesser than minus 5. And as the voltage across the collector, goes lesser than minus 5, like minus 6, then if you'll compare with the VB, you'll get to know the VB is at higher potential than VC. Then what would happen? This particular junction would go into the forward bias. Could you understand what I'm saying? This voltage is straight away challenging the collector voltage, and the collector voltage is straight away challenging the VB. It is just saying, my dear friends, keep my VC greater than VB, then only I would be keeping collector to base junction reverse bias. And if the VC goes lower than VB, I would become forward biased. So the voltage VB, which is equals to of minus 5 volt, has to get compared across the voltage across the capacitance. So I would just be comparing this as 5 volt. Yes. Tell me how much answer we are getting. Probably the T which we are getting is 50 millisecond. Agreed? And as this BJT goes into the active region, saturation region, the voltage across this BJT would get fixed to VCE set. Even they may design this problem also. Could you understand what is happening with this circuit? because many of us used to have doubt. See what is happening. At very beginning it is off, the voltage across the capacitance, sorry, at very beginning it is on, the voltage across the capacitance is 0, the voltage across the collector terminal is also 0, and when we took few number of operations, we got to know the collector to base voltage is positive. What does it mean of it? Really it is an active region. But as the switch got off, this current is fixed, even the collector current is also fixed. So the rest amount of current has to come through the 5 microampere, and that 5 microampere will charge that capacitor linearly, and as the voltage across the capacitor is getting charged, even the polarity is equally important. The polarity was like this, so here it was becoming minus, here it was becoming plus, and as the voltage across this terminal goes lower than minus 5 volt, in that case the junction which was VBC in reverse bias will come into the forward bias, and now you will leave your active region. That means the reference voltage across the capacitance has to be taken in terms of 5 volt. So I would see how much time was taken by the capacitance to reach its voltage as 5 volt. So I just calculated this. And I got to know the 50 millisecond time it would take to reach or to bring the voltage across this collector terminal as minus 5 volt, and that's the point. After that the BJT would go into the saturation region. Yes, saturation region. That's fine, no, minus 5 volt. I have just calculated in terms of their magnitude. You can do like this, yes. The last problem of the day. So here goes the last problem. Where it is, 10th problem. And I have seen more or less this sort of problem have started coming in a gate examination, where we had to do the DC as well as AC analysis over the same circuit, or I can say we are dealing with the quiescent operation of the diode. Let me enlarge this circuit a bit. Let me see what the problem indicates. The circuit shown in figure, the power supply, it's a V plus, has a DC voltage of 10 volt, which is superimposed a 50 hertz sinusoidal voltage of 1 volt peak amplitude, not peak to peak amplitude, it's a peak amplitude. That means it has been superimposed with sine omega t, where the omega is also been given, that's a 50 hertz, that's fine, no issue. Yes. Calculate the amplitude of the sine wave signal appearing across its VD. Here it's a VD, or you can write V naught. Assuming V cut in is equals to 0.7, nu, which is ideality factor as 2, and Vt is equals to of 25 millivolt. Tell me what would be the best most answer? See, they have been clearly said they wanted to know where it is peak AC voltage. That means you had to simplify, or you had to replace this diode into form of its AC equivalent. Anyways, how the diode would get replaced in a form of its AC equivalent? My dear friends, it has to get replaced by its dynamic resistance. Maybe it will get replaced by its diffusion as well as transition capacitance. Capacitance has not been given along with this problem, so keep aside for the time being. Now you can see very well, if you will see the VI characteristic of the diode, how the dynamic resistance was being defined. The dynamic resistance was defined by the rate of change in ID versus the change in VD. The rate of change in ID versus VD, and which was 1 upon R dynamic. Yes, 1 upon R dynamic. If the diode is adequately forward biased, the diode current ID could have been written as I naught e to the power of Vd divided by of eta Vt. Yes, for the dynamic resistance we are looking for the slope, which is nothing but the rate of change in current with respect to the rate of change in Vd, which is simply equals to of 1 upon R dynamic. R dynamic. Yes. If we will take the differentiation both other side, here it would become nu Vt would come towards the denominator side, and I naught e to the power of Vd divided by nu Vt would remain as it is. Would remain as it is. May I know what exactly this expression states? It states R dynamic is the function of Id. What I am saying? R dynamic is the function of Id. If the Id changes, R dynamic changes. Or you can say if Id increases, R dynamic decreases. If Id decreases, R dynamic increases. You can see very well, my dear friends, as you are going towards a higher value of Id, here the Id is more, no? You can see very well the slope is more, and the slope is more. Slope is not R dynamic. The invert of the slope is R dynamic. Here the slope is higher, R dynamic would be lesser. R dynamic would be lesser. What does it mean of it? That means until and unless you do not exactly know how much value of Id was offered, you would not be able to get the value of R dynamic. You would not be able to get the value of R dynamic. Now, one of the best thing about it, this Id, should it be asked from this plus 10 volt or plus 10 plus of 1, plus 10 minus of 1? Keep in mind, that is why the DC voltage used to be much higher than the applied time varying signal, and it's also called a small signal. One person was asking at very beginning, sir, what does it mean by the small signal, my dear friends? It is a small signal front of its biasing. So in future, if one gets added or one gets subtracted, definitely the operating voltage of Vd, if one gets added, it would come somewhere here. If one gets subtracted, it would come somewhere here. But in both of the reason, the slope is almost same. The slope is almost same. So rather calculating slope at a certain fixed value, just I focus over the slope at the DC operating condition. But that's true only and only. That's true only and only if this is much higher than this value, and that we do even in BJTs when we deal with the small signal. Nobody could have understood one important thing. The BJT experiences both current. No? Always. Anyways, let me go back. The BJT experiences both current. When the DC is being applied, the AC is being applied, the DC current is also there, AC current is also there. Many of the time student thinks, sir, when we do the DC analysis, DC current would be there. When we do the AC analysis, the AC current would be there. My dear friends, that's just an approach. Otherwise, practically the DC as well as AC current both would flow together. But the impact of Re would come because of only and only DC component. Why? Because the DC component would be in millis and AC component would be in micros. And that is why they are said to be a small signal. A small signal in front of what? It's on bias voltage as well as current. The same thing is happening along with this. Now, if they could have applied a time varying sinusoidal signal like 10 volt plus of 10 sine 2 pi 50t. In that case, such a huge variation of Q point would take place, you would not be able to decide its R dynamic. That is why I used to say, whenever we are dealing with the BJT based circuit, MOS based circuit, or maybe diode based circuit, the input signal which comes into the picture in compare with the DC biasing, they used to be small signal. Agreed? Know what I am saying? So ID can be easily calculated. ID would be equals to of, see my dear friends, it's simply gonna be 10. V cut in is known to me. V cut in is nothing but 0.7 divided by of 10 kilo. Yes. So here you would be getting the value of R dynamic. You would be getting, sorry, not R dynamic, you would be getting the value of ID. This ID has to be fed over here. You would be getting the R dynamic. And when you, in future, if you will be calculating the output voltage, AC output voltage, you had to just do one thing. You had to replace this as R dynamic, and the output voltage, output peak voltage would be R dynamic divided by of R dynamic plus of 10 kilo into the maximum input time varying voltage, which is nothing but 1 volt, which is nothing but 1 volt. Anyways, I have calculated this, so simply I would be writing somewhere. Millivolt we have to calculate, no, milli is already been written over here. So the answer which we are getting now, it's simply gonna be how much it is, 5.35. Anyways, could you understand this concept? What exactly I wanted to communicate over here? What exactly I wanted to communicate over here? So probably the concept of the small signal must be known to all of us. Like many of us may ask, sir, how could you calculate RE is equals to VT divided by capital IE, where the capital IE is DC current. Now any of us may ask, sir, along with the DC current there would be AC current. Because of that AC current, why don't the RE change? No, my dear friends, RE won't change because capital IE, which is a DC current, is much higher in compare with the AC current. Yes. So each and everything is perfect. If it is perfect, just write perfect, and then I would just end my today's session. Just wanted to ask, because this was my first class over the GATE Academy, did you enjoy this class or not? Just wanted to have one feedback. Did you enjoy this class or not? Because this was my first class over our GATE Academy. Obviously, the channel is global. Just wanted to have the feedback. And anyways, today's session would be over. We'll be meeting probably with the next session with the EMFT. Perfect now? Okay then, bye-bye. Take care. And before, perfect, no sir? Yes. Okay then, bye-bye, take care. We'll meet with the next session probably maybe tomorrow with the EMFT. Anyways, whatever the session would be planned, definitely you would come to know about that session with our Telegram group. We'll meet. Agreed? Thank you. Thanks a lot.